Hi, I'm Andrew Marcinkevichus, and welcome to Web Development with Node.js and MongoDB, video course by Pact Publishing. I am a professional web developer and have been developing web applications for more than 5 years. During those years, I made web applications for small businesses, government agencies, and startups. Always looking for things to learn and teach. You can learn more about me on my website. You can also connect with me on Twitter. Custom web applications expand to various topics. During this course, we will learn about them to be able to combine them. This video is an overview of the course to provide you with a glimpse of what you will learn. The course is made up of 8 sections, each teaching a different aspect of making web applications. The purpose is to learn how each of them combine to provide with a working application. We will discuss some theory to understand the important concepts. The focus, however, would be on the practical side to learn by building. In the first section, we will learn what Node.js is and how to build applications with it. In the second section, we will learn what Node.js applications are made from. The third section, we will learn about Express.js and start building our sample application. In the fourth section, we will learn how to persist our data in the MongoDB database. In the fifth section, we will learn how to serve and consume RESTful APIs. In the sixth section, we will learn how to test our applications. In the seventh section, we will learn how to package an application and deploy it to the cloud. In the last section, we will learn how to improve the application and its performance. The goal of the course is to learn how to create custom web applications. In this case, it is an application for collecting user feedback on workout events. It will get the events from the Meetup API and display it for visitors. Visitors can authenticate in the application. The authenticated users can leave their feedback for an event. The course will teach you how to use Node.js, Express.js, and MongoDB. It will provide all the code examples for you to execute and investigate. A few homework assignments are provided for those who want to get a better understanding of concepts. As a prerequisite, you should have basic knowledge of HTML, CSS, and most importantly, JavaScript before starting the course. Now, let's learn how to make web applications from the ideas you have in your head. Let's get started. Getting to know Node.js. Before we start making custom web applications, we need to learn what Node.js is. We're going to look at the basics of it and blocking versus non-blocking code. We will also set up our development environment and make a simple Hello World project. We will start with Node.js basics. In this video, we will look at Node.js fundamentals, the common use cases when Node.js is used, where it shines, or where you might want to avoid it. Node.js is an asynchronous, event-driven framework built on Chrome's V8 JavaScript engine. It's lightweight and efficient, making it a great choice for building scalable network applications. HTTP is a first-class citizen in Node.js, designed with streaming and low latency in mind. Node.js is single-threaded and uses an event loop. Rather than blocking the program, it registers a callback and continues. This allows it to scale well by handling concurrent operations without complication of multiple threads. Other languages have event loop systems, but in Node.js, they were designed to be non-blocking from the start. Modules are pieces of code for doing a task. They don't share the scope and are cached to avoid being executed multiple times. A callback function is invoked once the asynchronous function has a response. Events are emitted to inform what is happening in the system. Streams represent an abstract interface for asynchronously manipulating a continuous flow of data. Node.js takes an error-first approach, meaning that the first argument for callback function is an error object. Node.js shines in real-time web applications, for example, a chat application. Node.js works very well as an API for NoSQL databases. Concurrent connections make it easy to work with queuing inputs and logging. Possible to manipulate data as it is being received. For example, encoding a video while it's being uploaded. Node.js can be used as a proxy for handling a lot of connections. Node.js is a great choice for server-side applications, which use NoSQL database and don't require to do CPU-intensive tasks. Most of the pros were mentioned before, so only a quick reminder of why you might want to use Node.js. Lightweight and efficient. Easy to scale. JavaScript can be used for whole stack. Manipulating data as it's being received. You don't want to use Node.js for CPU-intensive operations. Your code should do what it needs to do as fast as it can and give back control to event loop. Node.js doesn't work well with relational databases. If you want to use a relational database, it would be better to make an application using a different language and use Node.js as a proxy. In this video, we learned what Node.js is, where it's used, and why you might want to use it. As you should choose the best tool for the job, we also learned when you might want to avoid using Node.js and use something else, which would be better suited for the task. In the next video, we're going to learn about blocking and non-blocking code, call stack, and command line interface. Hello to the blocking versus non-blocking code video. In the previous video, we looked into Node.js basics. We learned how it works, when you might want to use it, and when you might want to avoid using it. In this video, we are going to learn a little bit more on how Node.js works. It's important to know how the tool works to know it's the one for the job. Otherwise, if all you have is a hammer, then everything looks like a nail. We will learn the difference between blocking and non-blocking code, the call stack, and CLI support in Node.js. Node.js runs on a single thread, but it's able to run concurrent operations because it doesn't wait until I/O finishes. To better understand non-blocking I/O, imagine making breakfast. Put water to boil. Put tea in a cup. Turn on the heat for the pan. Break the eggs into the pan. Put water in a cup. Check email. Turn eggs over. Get the plate. Put eggs in plate. Eat your breakfast. As you can see, you don't wait for the tea to be ready before starting on your eggs. This way, you're always doing something and enjoy your tasty breakfast much faster. If your code executes an external program, it's doing I/O. For example, Hello World won't be an I/O operation as it happens in your code. Printing the Hello World, which is being read from a file, will be an I/O operation, as reading the file has to be given to a utility which does that task. I/O tasks can be really slow and resources are wasted as nothing else is being done until the task completes. Applications in Node.js run on a single thread, which means they can do only one thing at a time. For that reason, you want to avoid doing any CPU-intensive tasks, as it will block execution for any other task. Look at the following code. You would expect to receive timeout output after a second from starting of the script. As you can see from the output, we receive it at the end. This is because the while loop blocked the execution of the code, and we needed to wait before it finished. For that reason, you want to finish tasks as fast as possible, as it might lead to an unexpected behavior. The call stack is the last in, first out data structure containing an address to which execution should return after function calls finish. It often contains local variables and parameters for each call. It's very helpful in debugging the application. Each executed function pushes on top of the stack. If too much is pushed on the Stack Overflow error will occur and the program will crash. For that reason, you want to avoid making too many function calls without them finishing. The call stack is composed of stack frames. The stack frame, which is at the top of the call stack, is the one which is currently executing. The stack frame usually contains the following items: arguments, parameters passed to the function, return address back to the caller, local variables of the function. In high-level programming languages, the specifics of the call stack are often hidden. It is still worth to know how it works to avoid issues like making too many function calls. If your tool is I/O-based, or you don't know Bash, writing command-line scripts in Node.js is a great alternative. To create a script, you put a node shebang at the top of the script and make it executable if you're using a Unix-like system. You can pass arguments to your scripts, which are available from argument vector and returned as an array. You will notice that the first element is node, and second is a full path to script. You can remove them by splicing the arguments array. If the script finishes without an error, it should exit with code 0. If an error occurred, then the script should exit with code 1 or higher. You can pipe the output of one command to become an input for another command. If you need, you can collect additional information by using prompts. This allows us to skip command arguments and can be used to create interactive scripts. In this video, we have learned a little more about how Node.js works, helping us choose it when it's the right tool for the job. We have also seen how Node.js can help us with writing CLI scripts. In the next video, we will start getting our hands dirty by setting up our development environment. We will look at how to install Node.js and NodeMon, which will help us with developing our applications. Hello, and welcome to the Setting Up Your Environment video. In the previous video, we looked at how Node.js executes the code and how useful it can be for writing CLI scripts. In this video, we're going to learn how to install Node.js on your development machine and other ways we could have completed this task. We will install a NodeMon utility to automate the restarting of applications after the code changes. If you would open the Node.js homepage, you should see a link to download it for your operating system. This will be different depending on your OS. We will look at how to install it on OS X. Click the link to start the download. Follow the instructions from the installer to install Node.js on your machine. After installation, you should get the summary window. You need to have the bin directory in your path variable. To check the current path, type the following in your terminal: If the bin directory is not in your path variable, type the following in your terminal. If you don't want to type this in your terminal every time, you should add that line to your bash profile. To check that Node.js is installed and working, execute the following command in your terminal, and it should output the version of the Node.js installed. Congratulations! You now have a working Node.js in your machine. Using the package from Node.js homepage isn't the only way to get Node.js on your development machine. You could install Node.js using Brew or a similar package manager for your operating system. A pro among all of them is that the installation can be done from the terminal, allowing to automate it. A con is that sometimes they can be outdated and it might not be possible to get the latest version, which is very important if, for example, a security issue was fixed in it. You could use Vagrant to have a development box with Node.js and other dependencies. A pro is that it makes onboarding new team members very easy, and you can have customized development machines. A con is that you need to install additional software products, and it might get resource intensive. You could use Docker, which requires less resources than Vagrant and allows more experimentation. A con is that setting everything up can take a lot of time and energy. I would suggest to look into it, as Hosting Solutions is starting to move towards Docker. If you want to learn more about how to run Node.js in Docker, you can read one of my articles. You could use a cloud hosting to use as your development environment. A pro is that your development environment will be almost the same as production environment, and it allows a lot of experimentation. A con of it is that it can get expensive, and it would be hard to work without an internet connection. You could use Ansible Puppet, Chef, or similar IT automation software products. This allows you to automate the setting up of your development and production environments. When you make a change to your code, the Node.js application requires a restart. You would normally press Ctrl+C to stop the application, press up arrow to get the last command, and then Enter to execute it again. After a while, it gets repetitive, not taking into account that you will forget to do it and then spend hours trying to figure out why nothing has changed. This is a perfect task to be automated. We will install NodeMon, a utility which monitors for changes and automatically restarts your application. We will learn later about the npm. For now, just execute the following command. Use NodeMon command in place of node command, and every time you will make a change, the NodeMon will restart your application. From now on, you can keep making changes to your source code without worrying about restarting the application. It saves a lot of time and effort that you can use for making applications. In this video, we have learned how to install Node.js and multiple ways of how it can be done. We installed NodeMon, which will help us in developing applications by automatically restarting them every time you change your source code. In the next video, we will create our first simple CLI application, and we will cover the basics of debugging your applications. Hello, and welcome to the Hello Workout video. In the previous video, we looked at how to install Node.js on your development machine, and how to automate restarting of the application using NodeMon utility. In this video, we will get some practice by making a CLI application, and learning how to debug when things don't go as expected. We will learn to create simple CLI application which will take a few arguments and output a workout. Start by creating a script file and adding the shebang as the first line. Make it executable and add a console.log to make sure everything is working before we proceed. If it outputs "it works" in the terminal, we can proceed. If it doesn't work, retrace your steps and make sure you have everything set up correctly. Remove the console.log from the code. The application will take two arguments. First is your name. The second is workout intensity. Set arguments as a constant from arguments vector, removing unneeded arguments. We set it as a constant as we don't expect to change its value. Next, set the name and intensity from arguments constant. If intensity arguments is not provided or not in a list of available intensities, we set it to low. We use let rather than var. Unlike var, which has a global or function scope, the let has a limited scope, avoiding a lot of problems. Let is part of the ES6 standard, so at the moment, to use that we have to set the script to use strict mode. Let's output some basic information to the terminal. The application will output random numbers for 4 exercises. As the code will be the same for each exercise, you don't want to repeat it for all of them. We will create a function that will output the exercises. As we assume low intensity is the default one, we set it at the top of the function and leave out from the switch statement. We generate the random number from interval and output exercise information. After that, we call the function for 4 different exercises. Now, if you call the application with your name and intensity, you should get similar output. If you leave the intensity or type one which is not available, you will get the low intensity output. Congratulations on making your first Node.js application. Occurrence of bugs is unavoidable when programming. Sooner or later, you will have to debug your application. One way of debugging would be to make sure you're informed when you make an error in your code. To install lslint, execute the following command. Let's configure our project to use ESLint. It will ask you some questions for configuration. After you answer them, it will create ESLint.rc file, which will contain the configuration for ESLint. Answer the questions depending on your project requirements. If you run it, you will notice that it gives indentation errors. Our code is following the indentation rules we want, so let's make a change in the ESLint configuration. If you run it again, you should have no errors now. Let's make an error deliberately and run ESLint again. You will notice it gives you a list of problems you should fix. ESLint can be a great tool to help you write better code. check the project website to learn more about it. The simplest way to debug your application is using console.log. This can be useful and fast, as long as you don't forget to remove them after you're done. This helped me notice that our application doesn't exit if the name is not provided. Let's add that check. We just improved our application by making sure the name is provided before continuing. Node.js ships with a debugger, which allows simple inspections of your code. To enable a breakpoint, add debugger to your code. We also add a variable to show how the debugger works. To execute the application using a debugger, use node debug. Typing help will give you all the available commands. You can use cont to continue and REPL command to evaluate code remotely. To exit the debugger, use Ctrl+C. See debugger documentation for more information. If you would like something outside the terminal, use Node Inspector. Install it by running the following command. To start debugging your application, run it using node-debug. Open the URL in your browser. From this window, you can debug your code. You can add breakpoints. You can add conditional breakpoints. You can continue the execution of the code. You can see the call stack, variables, objects and functions. This will make it easier for you to debug your application. See the project website for more information. In this video, we have learned how to make a CLI application and how to debug it using different tools. In this section, we learned a lot about Node.js. We learned its fundamentals and when you might want to use it or avoid using it. We learned about the difference between blocking code and non-blocking code. We learned how to install Node.js and set up your environment for making applications. In the next section, we will learn about parts that make up the Node.js application. We will learn the common JS concepts, how to use NPM, what is an event loop, what is an event emitter, and how to work with streams and files. Hi, and welcome to the second section, Understanding Node.js Apps. In the previous section, we learned Node.js basics, how to set up a development environment, and how to write CLI scripts. In this section, we will learn what Node.js applications are made from. We will also learn about common JS and how it helps us to make our code modular. We will then understand about NPM, the Node.js package manager. Then, we will dive into what is event loop and event emitter. Last but not least, we will see how to work with streams and files. Now we move on to the first video of this section that deals with common JS. In this video, we will learn what is common JS, how to organize modules, how to import and export them. Common JS is a group with a goal to build up a JavaScript ecosystem and standardize multiple issues. One of the standards they ratified is for modules. Modules allow you to keep your goalscape clean, make it easier to test and share your modules. To use a module, we need the require function, to which we will provide the name of core library or file path. If you provide the file path, you don't need to add the JS suffix. For example, the following line imports the Node.js core file system module. If you want to import the local module, provide a path to it. You can provide the relative or absolute path. We don't have our hello module, so let's create it. You can see that we can make modules by using module.exports. In this case, we exported a simple string value. You can export functions. You can export objects too. Any property exported this way will be available as a value from the require function. Or you can import only the property you need. Each script has its own scope, which means that including them does not pollute the current scope. You should include module in each file where you need it, and modules are cached automatically. As you have learned, modules can be imported in 3 different ways: using relative paths, using absolute paths, and by using a name. Using a path is simple. It just loads the module from the file. When you import the module by name, it looks at core modules or /node_modules directory. You can create your module in node_modules directory, but you should use npm for managing your modules. We will learn about npm soon enough. In this video, we learned what is CommonJS, how to declare your modules, how to import and export them. Having modular code will make it a lot easier to test and maintain. In the next video, we will learn about npm, the package manager used by Node.js. Hello and welcome to the npm video. In the previous video, we looked at what is CommonJS and how to use it to write modular code. In this video, we are going to learn what is npm, how to install it, and how to manage packages using it. npm is the package manager for Node.js. It helps you share and reuse code. If you installed Node.js, the npm client should have been installed together with it. To check that npm is working on your machine, type the following command in the terminal. This should display the version of npm installed on your machine. Even though you don't need to install npm separately, it's updated more frequently than Node.js. You can update your npm client by running the following command. This will install the latest version of npm on our machine, but we will do that a bit later. npm has an extensive documentation. In the web, everything is changing at a fast pace. If something is not working, or you forgot how a command works, you can always check the documentation. As you can see, you get a video and a text description of how to install Node.js and update npm. One of the problems that you can run into is an EACCES error when installing packages globally. In that case, you can try installing packages globally by adding a sudo to the command. Otherwise, choose one of the options for fixing this problem and follow the steps to accomplish that. Let's do it using the second option. Make a change in the npm configuration. Next, add the bin path to your path environment variable. For that, you need to update .profile, .bash_profile, or some other file. You will notice that I have my path variables in a file which is loaded by .bash_profile file. After you have done that, update your system variables And now you should be able to download packages globally without using the sudo. We will learn about package.json and how to publish packages in later topics. For now, let's learn a few commands which we'll be using while developing our application. You can install packages globally or locally. You'll want to install command line tools globally. If your application depends on some module, you will want to install it locally. To install a package, we use npm install command. If it has a flag --global or shorthand -g, it will install that package globally. If you recollect from our previous topic, we installed node-mon using the following command. It's your preference if you want to use -g or --global. They are the same thing. If you want to install a package locally, just don't use the global flag. You will see that it creates a node_modules directory and downloads the package. If you're using a version control system, most of the time you will not be committing it. If you're creating an application, you will want to save a module as a dependency. That way, running npm install will install all the dependencies needed for your application to work. We will learn about package.json in a later topic. For now, just create a file containing a hash. Now, if you will add --save, flag the package will be added as a dependency in package.json file. To save a deployment dependency, use --save-dev flag. Development dependencies won't be downloaded on the production environment. You can specify the version of the dependency. npm does a good job doing it automatically, but if for some reason you want a specific version, here are some choices. We will learn more about semantic versioning in a later topic, but for now, you should be safe using caret dependencies most of the time. To install a specific version of the package, provide the version after package name. Running npm update will update packages. If you want updated dependency versions saved in package.json, add --save flag to command. If you want to update a global package, just add --global or -g flag. To find out which packages you have installed, use the following command. You can change how much of a dependency tree is displayed using --depth argument. If you want to list global packages, just add --global or -g flag. You can check for outdated packages using the following command. As you can see, this will show the current version, the wanted version, and the latest version. Like before, if you want to check for outdated global packages, just add --global or -g flag. If you don't need the package anymore, you can uninstall it. This will remove the package from node modules directory. If you would like to remove the package from package.json file, you need to add the --save, --save-dep, save-optional flag to remove it as an associated dependency. If you want to uninstall global package, use --global or -g flag. If you need to get information about package without using the browser, you can do this with the following command. You can specify the field you want. In this video, we learned what is npm, how to install it, how to fix the permissions problem if you have it, and how to manage packages. Well done! We learn more about npm later, but for the time being, you have learned how to manage the dependencies of your project. In the next video, we will learn about event loop and event emitter. Hello, and welcome to the event loop video. In the previous video, we looked into npm, what it is, how to install it, and how it allows us to manage our dependencies. In this video, we are going to remember what the call stack is and how it works. We will learn about the event loop and event emitter too. If you will recollect from the previous topic, here are the main points of the call stack. The call stack is a last-in, first-out data structure containing an address to which execution should return after function calls finish. It's made from stack frames, which contain local variables, parameters, and return address. It's useful for debugging, as you can get the path of what code was executed before an error happened. Let's see the call stack in action. We have a simple script with few functions and local variables. If we inspect it in Node Inspector, you can see the call stack and scope variables. You will see that call stack already has stack frames for our currently executing script. Let's add a few breakpoints to pause the execution so we could see the call stack in action. After adding the breakpoints, resume the execution of this script. The bar function will now be executed. As you can see, the bar function call is added to the call stack, and below you can see the scope variables. We called the foo function, and it's now added to the call stack. You can see that it was called with x and y variables. Resuming the execution will finish executing the foo function, and will remove it from the call stack. As you can see, we have no foo on the call stack. The console.log function is executed too fast to see on the call stack. As it's being run, it would be added at the top of the call stack. After the bar function is done executing, it's removed from the call stack. All other functions finish executing and our call stack is empty. You will remember a warning to avoid making too many function calls. Breaking things is fun. Let's do that. We have a simple script which calls a function. That function calls itself. As you can see, the stack frames with foo function call are being added on the top. If we remove the breakpoint and continue the execution, it will crash in the end. The JavaScript concurrency model is based on the event loop. It's made from three parts: the call stack, the heap, and the message queue. We already learned a lot about the call stack. Heap is a large region of memory where objects are allocated. The message queue is a list of messages to be processed. Each of the message has a callback. Once the call stack is empty, the message from the queue is being processed by calling its callback function. Once that message is processed, there is nothing in the call stack. The next message from the queue is processed. In short, it's a while loop which processes messages as long as we have them. Node.js runs on a single thread, and all the messages are being executed completely. For that reason, you don't want message execution to take a long time, as it will block your application. If you need to do a long-running or CPU-intensive task, it's better to run them in separate processes. You can add messages to the queue using setTimeout function. You can provide the delay in milliseconds as second argument. This doesn't mean that the function will be executed exactly after the time passes. What it means is that the minimum time required before a function is executed. As you can see, we have a simple script which logs some text to the console. The setTimeout function calls add the functions to the message queue. Only after the whole script has finished executing and call stack becomes empty are the messages from the queue moved to the call stack. Event emitter is a generic wrapper to simplify creating event-based APIs. Functions can be attached to objects, and when an event is emitted, those functions are executed. Those functions are called listeners. You can access event emitter with events module. You can add a listener with addListener or on methods. If you want the listener to execute only one time, use the once method. To emit an event, use an emit method. Listeners can have arguments, and you can emit events with arguments. You can remove a listener with removeListener method by providing event name and listener function. With removeAllListeners method, you can remove all the listeners. Calling listeners method with an event name will return an array of listeners for that event. You can add the same listener multiple times, but calling removeListener method will remove only one of them. When you add too many listeners, a warning will be given. If needed, you can change the max amount of listeners for a particular event. New listener and removeListener events are always executed when you're adding or removing events. It's very easy to create a module which extends from an event emitter. You first load until and events modules. Next, we initialize the necessary properties from the event emitter in this instance. Then, we inherit functions from event emitter's prototype and export the module using module.exports. This is all that's required to export a custom event emitter. To make it more interesting, let's add a listener and emit a new mail event. We need a self variable which will keep the reference to our instance. Then, you can add more listeners, emit events, or import it as a module. In this video, we learned how the call stack works, how event loop works, and how to use event emitter to create applications based on events. Wow, we've covered a lot in this topic. I hope you're excited about what we can do with this information. In the next video, we will learn about streams. We will understand what they are and how to use them in our applications. Hello, and welcome to Working with Streams video. In the previous video, we looked into how the event loop and event emitter works. In this video, we are going to learn about streams. We will learn about what they are, why we should use them, and how to make our own streams. The stream is an abstract interface which is implemented by various objects in Node.js. It's an alternative way to access data from various sources. Using streams, you don't need to have all the data available in your memory before you start manipulating it. This way, rather than loading the whole file in the memory, you can process it using small chunks. All streams are instances of event emitter, but they have custom methods and properties depending on the stream type. Streams can be readable, writable, or duplex. A readable stream is a source of data from which you're receiving data. The readable stream will not start emitting data until you're ready for it. The readable stream can be in one of two modes, flowing or paused. In flowing mode, you will get data as fast as possible, and in paused mode, you have to read data manually. Streams start in paused mode, but you can change the mode. To switch to flowing mode, add a data event handler, call resume method, or call the pipe method with a writable stream. You can switch to paused mode by calling the pause method. if there are no pipe destinations, or removing all data event handlers and pipe destinations. If you want to read data manually, you have to listen to readable event and use read method on the stream. You can see from the script that we create a readable stream for input.txt file. If the stream is readable, we read it in 9 bytes chunk until we have no more data to read. This script produces the following output. As you can see, we are receiving buffer objects. If you want to read data as a string, you need to set the encoding for it. If there was an error while receiving data, an error event would be emitted. You can list it to an error event and add a custom listener to handle the error. You receive data in flowing mode and add data event listener. By using pause and resume methods, you can control the flow of data. You should get the following output. A very powerful thing you can do with streams is to pipe a readable stream to a writable stream. This way, you can manipulate data as it's flowing. Like with Unix pipes, the idea is to combine commands to solve complex tasks. Streams can be piped using the pipe method. Running the script will read the data from file and output it in the terminal. Pipe method returns the destination stream so you can chain streams. Writable streams is a destination where you're writing data. Use the write method to write data to destination. Write method returns true if you should continue writing, or false if you should wait before writing again. Once you have no more data to write, you should call the end method. If end method was called, the finish event is emitted. You can't write to the stream once the end method is called. If you want to implement a stream, you have to extend the base class and implement specific methods. Let's take a transform stream, which will take the number and output if it's even or odd. First, we will inherit from the base class. Next, let's call the parent class constructor. And then we implement the specific methods, in this case, _transform method. This is all that is needed to make custom streams. At the end, it doesn't do much, so let's add some code. The next function, which will check if number is even. Using the push method, we output the transformed data. Once the current chunk is completely processed, we will call the callback function. Export this module so we can use it elsewhere. The script we will run will take the input from std_in, pipe it to our transfer stream, and then pipe it to std_out. You can use a simplified API to create custom streams. You just have to provide the specific methods in a constructor. Congratulations! Now you know how to work with streams. If you want to learn more about how to use streams, read the documentation. In this video, we learned what streams are, how to use them, and how to create custom streams. In the next video, we will learn how to use the file system module to manipulate the files. Hello, and welcome to Working with Files video. In the previous video, we looked into what are streams, why we should use them, and how to make your own custom streams. In this video, we are going to learn about files. We will learn how file system is defined in Node.js, and how to manipulate the files and directories. The file system are methods and data structures which define how data is stored and retrieved. In Node.js, manipulation of files can be done using file system module. It's a wrapper around standard POSIX functions. all methods provided by the file system module has synchronous and asynchronous methods. Synchronous methods has sync in their name. You should use synchronous methods when launching your application, and it can't function without a successful operation. For example, loading a configuration file, if it fails, you stop the execution of the application. Synchronous methods throw an exception right away if they don't succeed. Most of the time, you will use asynchronous methods, which take callback as the last argument and error as the first argument. If an order of execution is important, you should chain the callbacks for asynchronous methods. As you can see, first we asynchronously open the file with open method. We open the file in the append mode, and if it doesn't exist, it will be created. The open method throws an error or returns a file descriptor, which can be used for file manipulation. After that, we write current time to the file. If it didn't fail, we output how many bytes was written and the string which was appended to the file. We won't be doing any manipulations, so we can close the file. In video 2.4, we learned about streams, and if you remember, you can create read and write streams. One of the use cases where you might want to use the streams is copying a file. You just create the read and write streams and then pipe the read stream to write stream. Using this method, you can copy files. Node.js file system module allows you to watch a file or directory for changes. This can help you create some very interesting tools. This feature depends on the operating system, so it might change depending on where you run it. The persistent option tells us if the script should continue watching the files. The recursive option tells us if subdirectories should be watched. The callback function for watch gives us the event that happened and the file name on which this event happened. If you need to read the directory, you can do that using readdir method. It will give you back an array with names of files and directories. You can make new directories and remove existing directories. To make a new directory, use the mkdir method. To remove a directory, use rmdir method. Each method takes the path and callback has only possible exception as an argument. Congratulations! Now you know how to work with files. Please read the documentation to find all the available methods provided by the file system module. In this video, we have learned how to manipulate files using the file system module. Depending on the application you are making, working with files can be a big part of it. In this section, we learned a lot of new concepts, which will be helpful in making our very own Node.js applications. We learned how to import and export modules using CommonJS. We learned how to use the npm package manager to keep our code modular. We learned how event loop works and how to make applications that run faster. We learned how to work with streams, allowing us to manipulate data on the fly and keep memory consumption low. In the next section, we will learn about Express.js, which is a Node.js web application framework. We will start building our web application, which will expand with more features as the course progresses. Hello, and welcome to the third section, Creating MVC Apps with Express.js. In the previous section, we learned what Node.js applications are made from, including how to work with streams and files. In this section, we will start building our sample application using Express.js framework. First, We will learn what is Express.js and why we might want to use it. We will then learn what MVC is and how it helps us build applications which are easier to maintain and test. We will also learn what is routing and how we can define routes to have dynamic applications. Then we will start building our sample application by generating its skeleton and adding user authentication. Then we will take a step towards how to use Handlebar's templating engine and how it helps us to present our data in different ways. Now, let's move forward to the first video of this section that deals with Express.js basics. In this video, we will learn what Express.js is, how a sample application using it looks like, and where we can get more information about this web framework. Express.js is a fast and minimalist web framework for Node.js applications. At the moment, it's the most popular Node.js MVC framework. Its philosophy is to provide small and robust tools for HTTP servers. It's a great solution for single-page applications, websites, and public APIs. It allows you to plug the libraries you need to build a solution for your problem. A framework is not required to make web applications, but it allows you to develop them faster and better. A framework is a tool providing a lot of solutions to recurring problems, like routing, for example. This allows you to focus on your specific problem and make a solution to it rather than writing code for the same problems. Express.js uses middleware to extend its functionality. Middleware is a function which has access to request and response objects. They can make changes to those objects or execute some other code to achieve their purpose. Let's make a simple Express.js application. First, let's import Express module and then create an application using Express function. After that, we will define what will happen when we get a request. The callback arguments are often shorthanded to rec and res. For our course, we will be using request and response, as I find it easier to understand and faster to type. You can actually replace the callback arguments with whatever name you want, and it would still work. In the end, we run app.listen method with the port number. App.listen is a convenient method for launching Node.js HTTP server. Before running the application, we need to install Express module with the npm install command. After it's done, run the Express.js application and open it in the browser. Congratulations, you just made your first Express.js application. If you get stuck or need a reminder on how something works, Express.js provides an easy-to-understand documentation. It covers multiple topics. The framework also provides a lot of examples to get you started. In this video, we learned what is Express.js and why you would want to use it for making your web applications. We have seen how a sample Express.js application looks like and where to find more information if you're stuck. In the next video, we'll learn about MVC pattern and how it helps us build applications which are easier to maintain and test. Hello and welcome to the MVC video. In the previous video, we looked at what is Express.js and why you would want to use it for making your web applications. In this video, we're going to learn what MVC pattern is, and how it helps make applications that are easier to maintain and test. Model View Controller, or MVC, is an architectural pattern that describes how your applications are structured and how they behave. It separates the responsibilities, which leads to code that is easier to maintain, test, and reuse. Model handles data and business logic. View handles the data that is presented to the user. A controller handles receiving user requests, getting the data from the model and then passing it to the view. You should keep your models fat and controllers thin. Controllers should be the glue for combining the model and the view. This structure allows us to separate business logic from the presentation, reducing complexity in large applications. This will allow you to develop your applications faster and of better quality. Please keep in mind that the MVC pattern doesn't translate well for the web, and most frameworks are actually request-response frameworks. It became a norm to call frameworks as MVC frameworks if they follow some rules of MVC. Let's see how those components interact together. First, the user initiates an action. For example, requests his profile details. The controller handles the request and requests for user details from the model. The model retrieves the data, applies any business logic required, and returns the data to the controller. The controller passes the data to the view to produce the required presentation of the data. The view generates the required presentation of data and returns it to the controller. The controller passes the response back to the user, giving him the profile details he requested. This workflow enables us to return different representations of the data just by passing the data to a different view. For example, if a user requested his details on the web page, he would get an HTML page. If he requested it through a RESTful API, he will get the details as the JSON response. Let's take our Hello World application and extend it to become an MVP-based application. Add the /users root to our application, and we will save the roots in the controllers directory. Then we will create our controller. We will use the Express.js router to define our roots and handlers for those roots. We will learn more about routing in the next topic. Let's define our root and export this controller as a module. We will import the user model and request data from it, a list of names. Normally, we would pass the returned data to the view, but in this case, we'll just output it to the terminal. After we have our data, we would pass it to the view and return the presentation to the user. In this example, we will just return an HTML file. Save this file in the controllers directory as user.js. The view file would normally take the data retrieved from the model and would produce a representation of that data. For simplicity's sake, we will just output some HTML. But this shows that your presentation should be separated from business logic. Save this file in the views directory as names.html. The model would normally return the data from some persistent storage. It would also apply any associated business rules on that data and return it to the controller. For simplicity's sake, we will just take a list of names, sort it alphabetically, and return it to the controller. This saves the file in the models directory as user.js. If you would run this application and open the users root, it should output a list of names in the terminal and display an HTML text on the page. In this video, we learned what MVC pattern is and how it allows you to write applications that are easier to maintain and test. To see the pattern in practice, we made some changes in our example applications to make it an MVC application. The benefits of this pattern would be easier to spot while making your course application. In the next video, we will learn about routing requests to have a dynamic application. Hello and welcome to the routing video. In the previous video, we looked at what an MVC pattern is and how it helps us make applications that are easier to maintain and test. In this video, we are going to learn how to route methods and paths, how routes are handled, and how to use the Express.js router instance. Routing defines how your application should respond to specific client requests. To define the route, you need an HTTP method, a path, and one or more callbacks for handling that route. If you would recollect from our Hello World application, we defined a route for the home page. In this case, the get is the method for which we're defining the route. The slash is the path on the server, and the function is our callback for handling this route. You can define routes for any one of HTTP methods. The most popular methods are get, post, put, and delete. To define the route for an HTTP method, use the method of the same name. For example, the following will define a route for the post method. Now, the response will change depending on the method used. The special method all handles all the HTTP methods. The handler will be executed on all the methods. You will notice that it has a next function call, which passes the execution to the next handler. Route paths can be defined as strings, string patterns, or regular expressions. Just use a string if you want to provide route path. Here is an example of defining a route using a string pattern. No matter how many O letters you will add, the same handler for the route will be called. The regular expression-based routes will match depending on the regular expression. The following route will match all requests which end with ULA in them. You can pass multiple callbacks for handling a route. This allows you to impose preconditions for the route, for example, checking what user is logged in. You can also modify the request or response before handling it. If you will call the next route, all the remaining callbacks for the route will be skipped. You can chain the route handlers for the same route if you are using the app route method. This allows you to make modular routes and reduce redundancy. If you would remember from the previous topic, you can make your routes modular by exporting them to the module. You do this by using the router instance. The rest is the same as when using the app instance for defining routes. You can attach the middleware for this router. And you can define the routes for it. To use it, you should just import your module and mount it to the app. In this video, we learned how to define routes in Express.js and how routes are handled. This will allow us to make dynamic applications by responding on the basis of a request. In the next video, you will learn how to generate the skeleton for our application and how to add user authentication to them. Hello, and welcome to the Scaffolding an App video. In the previous video, we looked at how to define routes in Express.js and how they are handled to produce dynamic applications. In this video, we are going to learn how to generate an application skeleton and how to add authentication to our application. To avoid repeating yourself, you can add an application generator which will create an application skeleton for you. Install the application generator using npm install command as a global tool. We are specifying that we would like to install version 4 of the generator. Using the express command, you can see how to use it and the options available to us. For the options, you can change how the generated application will look. If you don't want to change the default configuration, All you need to create a new application is to provide the name. For this course, we will be creating an application which functions as a feedback manager for workout events from meetup.com. We will be using handlebars as a view engine. We will learn more about handlebars in the next video. To generate our application, run the following command. As you can see, the generator creates some files and gives instructions on how to launch your application. First, you need to install all the dependencies for the application. After installing all the dependencies, run it using the npm start command. You will notice that before running the command, we set up a debug variable. If this variable is set, the Express.js will output more information which can be useful when developing the application. If everything is working correctly, you should see a Welcome to Express message. Let's make a change to be able to use NodeMon for our application. Now, if you will make a change, the application will be restarted automatically. You can see from the application structure that root directory is actually our controllers. You can rename it if you want, but we will leave it as is. As you will remember from before, middleware is a function which has access to request and response objects. By manipulating those objects or executing other code, it allows us to extend functionality and achieve what we want. Our generated application already uses some middleware for parsing request body, parsing cookies, logging, and serving static files. If you want to learn more about middleware options you can use and how to use it, check out the documentation. Most of the applications you will make will require authentication. We will expand our application with a middleware called Passport to achieve that. You might notice that the code is a little bit different from the generated one. I made some changes, like changing shorthanded variables to expanded ones, and changing tab size to 4 spaces. Take the change code if you want to follow along. Using the npm install command, install Passport module and local strategy as dependencies. We will create a Passport.js file which will contain our configuration for authentication. First, we will import the required modules. You will notice that we will be using an object-based mock database before we will connect a real one. Then, let's define the strategy which will use username and password to verify our users. This function will load the user from the database and then make some checks to make sure no errors have occurred and the user is the correct one. To authenticate between requests, we will use sessions. We configure that only user's ID should be serialized. When deserializing the user, we will use the ID to find it in the database. We need to install the session module as a dependency using the npm install command. After it is installed, use it as a middleware and initialize the Passport module. Let's add our fake database. It just contains some records in the array and has 2 methods for retrieving those records by using one of the fields. Now, let's define the login and logout routes. This defines the login route, which displays the form or does the authentication on the form submission. The logout route logs out the user and redirects him to the home page. If the user was authenticated successfully, we want to redirect him to the profile page. We need to create our form for users to be able to log in. It's just a simple form with 2 fields. At the moment, no errors are being displayed on the failure. Let's fix it by adding Flash messages. We will need to install Flash middleware and load it. Configure authentication to set Flash messages and add an error to the view. Now, on the failed authentication, an error message will be displayed to the user. The only problem with our authentication is that the profile page should not be displayed if user is not logged in. We can fix this by adding middleware, which checks if the user is logged in, and if not, then displays the login page. Install it using npm install command and add to our profile root. Congratulations, you just added authentication to your application. In this video, we learned how to generate an application skeleton and how to add authentication for users. In the next video, we will learn how to use Handlebar's templating engine to generate our presentation of the data dynamically. Hello, and welcome to the Templating with Handlebars video. In the previous video, we looked at how to generate our application skeleton and how to add user authentication. In this video, we're going to learn how to use Handlebars to present the data dynamically. Handlebars is a template engine which allows you to render templates on the client or the server. When you are developing dynamic applications, you need to change the HTML dependent on the data. Templating engines enable you to do that. With Handlebars, we will write normal HTML with some expressions that change the output. To output the variables provided to the template, you need to wrap it in double curly braces. The value that will be added to the HTML will escape. This is great for security, because it helps us to avoid cross-site scripting, as user-provided input should not be trusted. Sometimes you might want to output the variable with HTML tags in it. This can be done using triple curly braces. Handlebars allow you to do conditional statements in your templates, using if you can output different markups when the condition is true. You can add else to output a markup when that condition is not true. Unless is different than if, because it outputs only if condition is falsy. For when you want to output lists, you can use each helper. This is a reference to the current element being iterated over. You can optionally add else to each, which will output content when the list is empty. You can change the content in which your template is being executed using with helper. We pass user object to it so we can use first name and last name variable as is. Then let's change the context to contacts, allowing us to just simply use Twitter to output its value. We can access deeper values without changing context by using the dot notation. Handlebars lets you render partial templates. This allows you to separate your templates into smaller pieces, making them easier to maintain and reuse. We need to set where our partial templates are kept using the register partials method. To use the partial, you should start with double braces, followed by greater than sign, and then the template name. If you wish, you can provide additional information to them. You can use the handlebars template in the browser too. First, we need to register the library, which you can take from installed npm module. This change will load the minified handlebars library in our pages, as it's now added to the layout. Let's create browser template by creating script tag with xtemplate type. You will notice that we escape handlebar helpers by adding a slash to them. This is so that they are not executed and added as they are supposed to be in the generated markup. Then we add the code which will comply our template in the browser, render it, and replace the existing HTML element with output from template. If your template is not working, you might need to restart NodeMon manually. Congratulations! Now you know how to generate templates to provide dynamic content from your application. In this video, we have learned how to generate our presentation of the data dynamically. In this section, we learned what is Express.js and why use it for web applications. We learned how MVP pattern allows us to make applications that are easier to maintain and test. We learned how routing is defined in the Express.js and how it handles routes to let us make dynamic applications. We learned how to generate an application skeleton and how to add user authentication to it. In the next section, you will learn about MongoDB database. It will add a persistence layer to our applications, allowing us to manipulate our data. Hello, and welcome to the fourth section, Persisting with MongoDB. In the previous section, we learned how to build an application using Express.js framework. In this section, we will learn how to persist our data using MongoDB database. First, we will learn what MongoDB is, why use it, and how to install it. Then, we will learn what NoSQL is and the various types of databases it provides. We will also learn how a schema looks in MongoDB, the available data types, and how to normalize or denormalize data. We will then look at how to use Mongo Shell to do CRUD operations by finding, inserting, updating, and removing documents. And finally, how to execute the same CRUD operations from Node.js. And as a bonus, we'll glance over Mongoose, how to install it, how to create our models, and how to protect our applications from malicious users. Now, let's move to the first video of this section that deals with MongoDB basics. In this video, we will learn what MongoDB is, why we should use it, and how to install it. MongoDB is an open-source, cross-platform, document-oriented, NoSQL database. It is designed for scalability and developer agility. It has a dynamic schema and stores JSON-like documents in binary JSON. It is between key value stores, which are fast and scalable, and between relational databases, which has rich functionality. It saves the data in a single document, meaning that an entity can contain all the information by itself. A lot of drivers are available, allowing us to use it with most of the languages. MongoDB provides a lot of features for which you might want to choose it as your database. It has ad hoc queries that enable one allowing to search by field, range, or regular expressions. It has indexing that allows us to index our data for faster lookup. Replication allows for high availability and eventually consistent data. Load balancing allows easy horizontal scaling using sharding and adding new machines on the fly. MongoDB can be used for file storage using grid file system. It's possible to process and aggregate data by using MapReduce. JavaScript can be used in queries and executed on the database. This allows you to use a single language for your whole development stack. Supports capped collections, which are fixed-size collections, help remove older records as new data comes in. MongoDB is a great choice if you have high write loads, need high availability, or you have a lot of data. Collections are schemaless, allowing you to add and remove fields without performance degradation or needing a database administrator. MongoDB has spatial functions built in, making it a great choice if your data is location-based. MongoDB is cross-platform, giving you a lot of installation choices. The download pages provide you with the installer for your operating system. They have installation instructions given step by step to help you out. For example, on OS X, you have a choice to install it using a package manager or manually. We will be using Package Manager to install MongoDB. Please make sure that you have Homebrew installed and working beforehand. First, update the package database of Homebrew with brew update command. Then, using the brew install command, you can install MongoDB on your machine. By following the instructions in your terminal, you can make MongoDB start at login or launch it using custom configuration. We will be using custom configuration for the rest of this course. To lower fragmentation, MongoDB allocates big files for storing data. To save space on your development machine, we will be using small files. Add the Small Files option to the configuration. Now we can run the MongoDB database with mongod command. To check whether it works, we can connect to it using Mongo shell. You should use authentication to protect your database, but for simplicity, we will use an unprotected database on our development machine. Congratulations! You have successfully installed MongoDB database on your machine. In this video, we learned what MongoDB is, why we should use it, and how to install it. In the next video, we will learn about what NoSQL is and the different types of databases it provides. Hello, and welcome to the NoSQL video. In the previous video, we learned what is MongoDB, why we would want to use it, and how to install it on our machine. In this video, we're going to learn about NoSQL. We will learn what this term means and the different types of databases under this term. After seeing the term NoSQL, it makes you think that it means no SQL. Actually, it is not only SQL, which means an alternative to SQL, which can still support SQL-like queries. NoSQL is a term used for databases which are not like traditional relational databases. The motivation behind NoSQL databases is simplified design, horizontal scaling, and finer control over availability of data. NoSQL databases are split into multiple types. In your most day-to-day development, you will use key value and document databases. Often enough, you will use both of them at the same time, as they provide solutions for different problems. Key value store databases are the simplest of NoSQL databases. They have no defined structure and work similarly like an associative array. The keys are unique in the collection and can contain any type of data. It's very easy to add and retrieve data, making them a great choice for problems where complex data structure is not required. For example, Redis is often used as a cache for applications. Here are some of the key value stored databases. Document store databases save data as documents in the collection. The idea is what the document contains or the information required to describe the entity. The documents are accessed using the unique key. Documents can contain subdocuments, and the documents in the same collection don't need to have the same structure. Here are some of the document store databases. You probably won't be using column and graph databases as often as other types. Column store databases are similar to key value databases, except it is more like two-dimensional array than associative array. They create collections from columns in the database and then use them to look up for data. Data doesn't need to be structured and can actually have completely different columns. This database type scales very well and is great if you need to store large amounts of unstructured data. Here are some of the column store databases. Graph store databases work well for the data which can be represented as a graph. Data is represented as nodes with connections between other nodes. This allows for an example to easily represent relationships of your friends on a social network. Here are some of the graph store databases. In this video, we learned what is NoSQL and what types of databases it provides. In the next video, we will learn about how schema looks in MongoDB, what data types we can use, and how to normalize or denormalize our data. Hello and welcome to the Schema and Data Types video. In the previous video, we looked at what NoSQL is and the types of databases it provides. In this video, we're going to learn about how schema looks in MongoDB, what data types we can use, and how to normalize or denormalize our data. MongoDB stores data in collections and it uses dynamic schema. For that reason, you will often come across the term schemaless when the topic is around MongoDB. Collections can have a lot of documents, and each of those documents can have a lot of fields. Each of the documents in the collection can have a unique combination of fields, and other documents don't need to have the same fields as other documents. This allows you to add or remove fields without making changes to other documents in the collection. That is why MongoDB is a great choice for prototyping or data whose structure can be changed in the future. In practice, your collections will contain documents with similar structure, but this is not mandatory as it is in relational databases. Transactions are not available in MongoDB, so you will want to avoid using it where they are important, for example, financial operations. Even if transactions are not available, there are strategies for solving this problem. In MongoDB, write operations are atomic within a single document. The maximum size of a document is 16 megabytes. Only in rare occasions will you reach this limit, but it's worth keeping it in mind when you're making your data model. There are some restrictions when naming your collections. Collection names can be any UTF-8 string. The name of the collection should begin with a letter or an underscore. It can't be an empty string. It can't contain a $sign or null characters or have system dot in it. For maximum flexibility, you should restrict the length of the name to less than 80 characters. Field names in documents also have some restrictions. The underscore ID field is reserved for primary key and must be unique, immutable and not an array. The field names cannot start with a $sign, cannot contain dot or null character. MongoDB fields can be of a lot of types with which you should be familiar. Fields can be strings, numbers, objects, arrays, booleans, dates, and of some other types. One special type is object ID, which is a 12-byte bson type. It is constructed from a 4-byte value representing the seconds since Unix epoch, a 3-byte machine identifier, a 2-byte process ID, and a 3-byte counter starting with random value. This object is used for _ID field, which acts as the primary key. If you use object ID for your primary key, you get the benefits that it's possible to access its creation time, and sorting by it is roughly equivalent to sorting by creation time. While modeling your data, you will have to ask a lot of questions on how it is structured. Choosing the right structure for your data will improve performance and make maintenance easier. One of the questions will be if you should normalize or denormalize your data. Normalizing data is when you move data to separate documents and include the ID to that document. This process minimizes redundancy and dependency. It makes your database smaller because only a single copy is kept. Only a single manipulation is required if you need to change that data. The disadvantage is that getting that information requires additional lookup, which can become a performance issue. Here, you can see an example of how the documents with normalized data strategy would look like. Denormalizing data is when you embed documents inside a document. Most of the time, it is done for one-to-one relationships or when data is small and doesn't update very often. The advantage is that you get this data with your main document, so you don't need to make an extra lookup. This data will also be changed on the same atomic write operation. The disadvantage is that this data might be repeated often, leading to multiple copies for each document. If this data is not accessed often, it adds an unnecessary increase in size for the main document. Here is an example of denormalized data. As you will notice, it is actually the same data, so it is your choice which strategy you use. In this video, we learned how schema looks in MongoDB, what data types we can use, and how to normalize or denormalize our data. In the next video, we will learn about using Mongo shell to execute CRUD operations by finding, inserting, updating and removing documents. Hello and welcome to the CRUD video. In the previous video, we looked at how schema looks in MongoDB, available data types, and how to normalize or denormalize our data. In this video, we're going to learn how to use Mongo shell to do CRUD operations by finding, inserting, updating, and removing documents. Create, read, update, delete, or CRUD for short, refers to 4 basic operations you do with your data. There are multiple variations for this acronym, but basically this refers to the largest number of operations you will be doing. Before we start learning those operations, we need to have some data we could play with. We will be using an example dataset provided by MongoDB. Save the dataset to your file system and then import it using Mongo import command. We will be using Mongo shell to interact with our MongoDB database. You can see that we are connecting to the test database. The shell has a DB variable, which is the reference to the current database that is automatically set to test. If you want to change the database, execute the use command with the name of new database. The help command and method is available if you need it. The output changes depending on the context. During this video, we will be using query selectors and projection operators to change how commands execute. We will not go into details about them. Please check the documentation page to see all available selectors and operators. The most important thing to remember is that operators start with a $sign. To find all documents, use the find method on the collection. This will return the cursor to returned data. You can iterate over the cursor using the it command. If you would like the output in a prettier format, add the pretty method at the end. We can add conditions to our queries. We can find all the restaurants which have Thai cuisine. This returns all the documents that have a Thai value for the field cuisine. We can add selectors to make our queries more complex. This will return all documents which have Thai as cuisine and the grade score is higher than 19. We can access the fields in arrays and embed documents by using a dot notation. We didn't provide which array element to match, so the query will match against all array elements. We can limit how many documents are returned by using the limit method. Or use the find_one method if we only need one document. We can add a projection that tells the query which field to return. Use 1 or true to do the inclusion, 0 or false for exclusion. You can only use inclusion or exclusion. The _ID field is a special case. It's included by default, but you can suppress it. You can add a new document by using the insert method. You can use the save method, which updates an existing document or inserts a new one. If you provide the _ID value and the document with that ID exists, it will be updated. Documents can be updated with the update method. Provide the selection criteria for the update as the first parameter. As the second parameter, provide the modifications to apply. You can update a specific field for the document with $set operator. This updated the age field with a new value, but didn't change any other fields. You can change multiple fields on the same update. If you want to replace the document, then provide the new document. The update method only updates a single document. If you want to update multiple documents, use the multi option. You can remove documents with the remove method. If an empty query document is provided, it will remove all documents from the collection. If you provide a query, it will delete the documents that match the criteria. If you want to delete a single document, provide the second parameter as true. In this video, we learned how to use the Mongo shell to do CRUD operations by finding, inserting, updating and removing documents. In the next video, we will learn about executing the same CRUD operations from Node.js. Hello and welcome to the Integrating with Node.js video. In the previous video, we looked at how to use Mongo shell to do CRUD operations by finding, inserting, updating and removing documents. In this video, we're going to learn how to do the same CRUD operations using Node.js. Now that we know how to use our MongoDB database, we need to know how to do those operations with Node.js. First, we need to install the MongoDB Node.js driver using the npm install command. We have to initialize the variables which will be used when connecting to the MongoDB database. The Mongo client will be used to connect to the database. The assert module will be used to check if connection was successful. The URL defines where is our database and how to connect to it. Check the documentation to learn more about how it's constructed and its available options. Then, use the connect method to connect to the database. Check that no error occurred while attempting to connect to the database. Congratulations, you are successfully connected to your database. Close the database once you're done with it. The operations you execute from Node.js are very similar to the operations you would be executing in the Mongo shell. We will be using the same example dataset from the previous video, and to import it, run mongo import command. To fetch the collection, use collection method on the DB variable. Now that we have our restaurant collection, let's find 5 Thai restaurants. As you can see, like in Mongo shell, we just provide the criteria for our find query. By using the limit method, we can limit our cursor, in this case, to 5 documents. With the toArray method, we can return an array of documents. The results are stored in the memory, so you need to make sure there's enough space for it. We also need to move the database close call, as our find function is asynchronous. We can go over the return documents by iterating the cursor with the forEach method. First, we need to get our cursor for the query. Then, using the forEach method, we should provide the iterator callback. And we need to provide the end callback, which is called on error, or when the cursor is exhausted. We can insert a new document using the insert1 method. The method will return an error on failure, or the results object if it was executed successfully. If we don't provide a callback to the insert1 method, it will return a promise. To resolve the promise, we should use the then method on success. We will use the catch method on failure. Both methods return a promise, and we can chain the promises. We will add the handler, which will be called even if our promise was rejected or resolved. If we wish to update multiple documents, we can do it by using the update many method. Just like with executing it in Mongo shell, we should then provide the filter for documents to be updated, the changes we want to make, and optionally the options. From our callback, we can check how many documents were updated. We can remove one document from the collection using the delete1 method. Please check the driver documentation to see all available methods and how to use them. In this video, we learned how to execute CRUD operations using Node.js. In the next video, we will learn about Mongoose, how to install it, how to create our models with it, and how to protect our applications from malicious users. Hello and welcome to the Mongoose video. In the previous video, we looked at how to execute CRUD operations using Node.js. In this video, we're going to learn what is Mongoose, how to install it, how to create our models with it, and how to protect our applications from malicious users. The database solves the problem of persisting our data. Most of the time, our data will have other requirements attached to it, like validation or business logic. We can fix it by using Object Document Mapper to our map, or data as objects in our applications. ODM abstracts usual operations with documents, providing us with utilities which simplify a lot of common tasks. ODM has an impact on the performance, but it's balanced by rapid application development, allowing you to develop your applications faster. We will be using Mongoose, an elegant MongoDB object modeling for Node.js. Mongoose provides us with schema-based modeling for our application data. Out of the box, it provides us with typecasting, validation, query building, business logic hooks, and more. Mongoose can be installed with the npm install command. After it's installed, you need to import it to app.js and set the database connection. We connect to our local MongoDB database and add a few handlers for connection events. After we have Mongoose working, we can start defining our models. First, we need to create a schema which maps to MongoDB collections and defines how our document will look and behave. We need to define our properties, which can be done by providing their type. We can also provide validations, like it having to be a unique value. We can provide the modifications to a property, like for an example, lowercasing it. We can define properties just by providing their type. We can make our properties required and add a custom message for when this validation fails. We can provide the default value for property. Schema functionality can be expanded by adding plugins to it. We will make our user authentication to use Mongoose. First, install the module with npm install. Then, plug it into our user schema. Change the passport configuration to use our user model. Let's add a registration route which will create a new user. We will collect data from our request for new user document. Then, we will call the register method provided by the Passport Local Mongoose plugin. After that, we will add a check to make sure we have no errors. As you can see, we can access the validation errors. Add the response on success, and you should be able to register a new user. If you will try to register a user with the same username, it will fail. We can add custom methods to our documents. To do that, assign a function to the methods object on the schema. We are using the template strings for return value. They are string literals that allow to embed expressions. We can find our documents by using an ID provided by the findById static method. For callback, we should check if our document was retrieved, and then we can call our custom method. We can test this with the user that exists and one that doesn't. Adding static methods is similar, except it's done on this statics object. To call the method, use the model name. Let's register a few more users to make the response interesting. This time, we are making a JSON request. We are looking for users who have Andrew as the first or last name. We can add virtuals which are document properties that are not persisted to MongoDB. Use the virtual method on our schema to define the full name property. You should use virtual properties just like normal properties. Middleware, also called hooks, can be added to the schema. For example, we can add a post hook which will be executed after the document is saved. There are multiple ways to update documents. One of them is to find the document you want, make changes to it, and then save it. This will fail because the value of age can't go below its minimum value defined by the validator. It is possible to update the document without retrieving it. You provide conditions, changes, and options to the update method. The third way is by using the findById and update method, which returns the document being updated. On update, validators are not run by default, and they only run on $set and $unset. Because validators were not run, we were able to remove the first name. You might have heard about SQL injections. It's a method to provide input which will change the database query to compromise the security. It is not possible to execute SQL injection on MongoDB database, but it's possible to do an injection attack. You can see that we can provide an input that modified our query to return all the results from the user's collection. To avoid that, we can use the $in operator to make sure that our query is not modified and values are selected as provided. Congratulations, you've just learned how to use Mongoose and protect your application. In this video, we have learned what is Mongoose, how to install it, how to create our models with it, and how to protect our applications from malicious users. In this section, we learned what is MongoDB, why use it, and how to install it. We learned what is NoSQL and the various types of databases it provides. We learned how a schema looks in MongoDB, the available data types we can use, and how to normalize or denormalize our data. We learned how to use Mongo Shell to do CRUD operations by finding, inserting, updating and removing documents. We learned how to execute the same CRUD operations in Node.js. In the next section, we will learn about RESTful APIs. It will provide different views on how we can consume them, and we will continue expanding our feedback application. Hello and welcome to the fifth section, Communicating with RESTful APIs. In the previous section, we learned how to persist our data using the MongoDB database. In this section, we will learn how to serve and consume RESTful APIs. First, we will learn what REST is, why we use it, what are the resources and methods in it. We will learn how Express.js helps to build RESTful APIs, how to plan your API, and what authentication choices are available for an API. Then we will dive into how to consume REST API on the server using the API module, the native HTTP module, and API REST client module. We will learn how to document our API, how to retrieve and manipulate data from an API on the client side. Last but not least, we will see how to provide CRUD through REST and how to aggregate our data. Now, we move on to the first video of this section that deals with RESTful APIs. REST stands for Representational State Transfer. REST is the software architectural style of the World Wide Web. It provides constraints which can be used to build REST web services for providing access to your data. The REST has the following constraints. Client-server means that uniform interface should separate clients from servers. This separation means that clients don't care how data is stored on the server, and server doesn't care what user interface the client is using. As long as they follow the interface, clients and servers can be developed separately. Stateless means that no context should be stored on the server, and each request should contain all the data required to process it. Cacheable means that responses must define how the client could cache the response if it chooses to. Layered system means that clients can't tell if they are connected to a server directly or not. This enables one to add intermediary servers that improve the system performance or security. Code on demand is the only optional constraint that implies that an API can return code which can be executed by the client. Uniform interface is for simplifying and decoupling. It is fundamental in REST. All the rules are flexible, which most often leads to a lot of arguments. To be on the safe side, most of the time it's better to refer to your API as RESTful. This means that it implements some of the constraints, but not all of them. What are the reasons you might want to make a REST API? It uses uniform interface and separates concerns. This allows you to reach a large number of developers who can consume your API. As long as the consumer and provider follow defined constraints, the clients and the API can be developed separately. By adding proxies, you can make an API easy to scale. You can wrap legacy applications or multiple applications under a single API to extend the functionality of those applications. It's simple to produce and consume RESTful APIs. REST APIs work by executing an action on the resource. Each resource should be unique and identified by the URI. You will want to avoid using auto-incrementing IDs for resources, as it enables to scrape and exploit your data. MongoDB provides us with IDs which are hard to guess. Otherwise, you might want to use Universal Unique Identifier. It might be tempting to use singular form when talking about a single resource, but it immediately becomes a headache. It's simple with resources like user or event, which become users or events for collections of resource. It would get a lot more complicated if, for example, we had to manage which city is the event in. For a single resource, it would be city, and for a collection, it would be cities. Just use plural to make your life easier and less confusing. The actions you take on the resource are based on the HTTP methods. The method can be safe or idempotent. Safe means that it won't change the resource. Idempotent means that executing it in multiple times won't change the response, but it can change the resource. The delete method is a special case, as it would depend on how your application implements the removal of resources. The HTTP method maps to the CRUD operations. You will be using get to retrieve resources and delete to remove them. The post is used for creating new resources and put for updating them. Here are some examples of what your API might enable your consumers to do, depending on the method and resource. Get/events will return a list of events. Get/events/x will return the event with the provided ID. Get/events/xyz will return the list of multiple events requested by the consumer. Delete/event/x will delete an event with the provided ID. Delete/events/x/feedbacks will delete all feedbacks associated with an event. Post/events will create a new event. Put/events/x will update an event with the provided ID. There is a lot more to the REST APIs than the scope of this course allows. Congratulations! You should now have a basic understanding of how REST APIs work. If you're interested in learning more about REST APIs, I would suggest a great book on this topic by Phil Sturgeon. In this video, we learned what is REST, why use it, what are the resources and methods in it. In the next video, we will learn about how Express.js helps to build RESTful APIs, how to plan our API, and what authentication choices are available for an API. Hello and welcome to the Serving APIs video. In the previous video, we learned what is REST, why should one use it, and what are the resources and methods in it. In this video, we are going to learn how Express.js helps us build RESTful APIs, how to plan our API, and what authentication choices are available for an API. Express.js allows us not only to build our web application, but also a RESTful API. It has built-in methods to allow you to build your API without having to solve repeating problems. If something is missing, you can extend it using middleware by using an already built one or writing it yourself. There are 4 levels of REST, and technically, only reaching the last one makes your API a REST API. If your API is at a different level, it's often called RESTful API. We can easily reach the second level by using resources. For example, you can have an events resource by providing a path to the route method on application or router. This has the benefit of allowing you to chain the routes without having to define the path. If you want to define your resources using individual methods, you can do that as well. We can reach the third level of REST by using HTTP methods. The app and router provides us with methods that map to HTTP methods. This makes it very easy to define actions on your resources. The Express.js application uses the body parser middleware to parse JSON requests, so you don't need to do anything yourself. You can retrieve sent data using request.params. After you are done, return back the response with JSON method. If you need to change the HTTP status of the response, use the status method. Here are some of the most often used statuses by their group. You can read more about them on Wikipedia. There are lots more methods which change headers or does something else that might be useful for your API. Please read the documentation to learn more about them. When making an API, you should start thinking about the resources and actions that will be available. This can be as simple as making a list of endpoints. This allows you to get a bigger view of how your API would look like. You need to decide on the data type and format that you will be using for the API. Unless you have some requirement to use a different data type, most of the time you'll be using JSON. For our API, we choose to use the data to be namespaced under data key, even if the response is a single resource. You can choose any format, but make sure that it is concise. You have to do the same for errors returned by your API. The HTTP status code is not enough, and you should always provide good error messages. For our API, we choose to output errors under errors key. Each error contains the code, status, title, and details. Unless you are making a read-only API, you will want to add authentication to it. There are lots of choices for authentication, and each of them has its advantages and disadvantages. HTTP Basic and HTTP Digest are very similar to providing normal login forms, except that you provide your username and password in the header. If you can, you should avoid using them, as they are not very secure. When using other APIs, you often get the API key, which you can use for consuming an API. This will often be for consuming APIs on the server side, as you want to keep that value secure. OAuth is often used to authenticate with third-party services for using their API. If you can, you should use the second version of OAuth. JSON Web Token authentication is very similar to normal login forms. You have to exchange your username and password once to receive the token, which you use for requests. It is good to use SSL as it improves security by a great margin and sometimes is even a requirement. In this video, we learned how Express.js helps us to build RESTful APIs, how to plan our API, and what authentication choices are available for an API. Great! How does it feel to have so much knowledge? I'm sure you're eager to learn more and keep moving forward. In the next video, we will learn about how to consume REST API on the server using the API module, the native HTTP module, and API REST client module. Hello and welcome to the Consuming on the Server Side video. In the previous video, we learned how Express.js helps us build RESTful APIs, how to plan our API, and what authentication choices are available for an API. In this video, we're going to learn how to consume REST API on the server using the API module, the native HTTP module, and API REST client module. When your application is built on top of another application, you will want to decide how you will consume their API. One of the choices would be to consume it on an as-needed basis. You will want to avoid this most of the time, as this couples your application and can lead to lots of problems. You can hit rate limits. Your application won't work if their application stopped working. It will require a lot of communication with API. Most of the time, you will want to keep the needed information on your own infrastructure and have an external ID for repeated processing if needed. For that reason, we choose to scrape the events and attendees from Meetup API. The scraper would run constantly to get new data and save it on our database. If, for example, Meeting API went down for maintenance, our application would still be working as we are serving from our database. You will notice that our application has changed a little from the last time. Changes made extend its functionality with middleware, adds configuration, and some style improvements. There will be some places marked with //homework comment. They are left as homework if you would like to get some practical experience by solving a few problems. We have a script which exports our configuration variables to terminal window. Normally, you would set them to be persistent on the machine, but for this course, we will choose to import them only on the terminal we need. When working with the API, first you will want to check if the module for working with it exists. This will simplify working with the API, as it will be made exactly for that reason. Install it with the npm install command. We will be saving our events with the following schema. You need to be authenticated to use the API. We will use the simplest choice of using the API key. Next, load the Meetup module and create the model method for getting the events. Define the options for the API call and make it using module method. In this case, getOpenEvents. After API returns a response, our callback will be called with the returned past events. To do this scraping, create a route for it. We add the query token because we don't want someone to execute this by knowing the path. Normally, you will add a call to this route to cron job to execute it constantly. Then, return the events from an API and save them to our database. Our SaveEvents method goes over the API results and creates Mongoose event documents. We need to make another call to get the attendees. Attendees is not that important for us, so if it fails, we just save the event. You could make another cron job which goes over the documents that have attendees count higher than 0, with attendees array empty. This job would make another call to try to get the attendees. We use async module to control our flow and process single operation at a time. To consume the API, we can use the native HTTP module. You will need to read the documentation to know how to consume it. We need to define the options for the request we want to make. Then, we make the request and define the events handler to process that request. ParseAttendees function goes over the API response and produces a list of attendees. JSON parse method is wrapped in attempt method, which is the wrapper for throw/catch. This is because JSON parse throws an error and you don't want your application to crash on invalid JSON. The third method for consuming API is using a module which is made for consuming REST APIs. Install it using npm install command. You would call the API by first registering a method for it. If needed, define the arguments for the call. This adds the benefit of easily configuring the API call, for example, adding or removing the parameters. Then, call the method which will return the data or emit an error event. Now, if you will call the scrape route, it should save the events retrieved from the API. This can take a while, but as it will be executing from a cron job, that's not a problem. After scraping, you should see the new events. Congratulations on learning how to consume REST API. In this video, we learned how to consume REST API on the server using the API module, the native HTTP module, and the API REST client module. In the next video, we will learn about how to document our API, how to retrieve and manipulate data from an API on the client side. Hello and welcome to the Consuming on the Client Side video. In the previous video, we learned how to consume REST API on the server using the API module, the native HTTP module, and the API REST client module. In this video, we're going to learn how to document our API, how to retrieve and manipulate data from an API on the client side. Documentation is the most important part of building your API. If others don't know how to use your API, they won't be using it. There are multiple choices how you can document your API, from simple text files to custom applications. The most important part is to document it. You can document your API with API Blueprint, from which you can generate a nice documentation or extend it with other tools. You write it just like normal text files with some syntax added. API Blueprint is a variation of Markdown syntax used to describe a web API. You can add sections, code blocks, links. Install Aglio using the npm install command. You can write whole documentation in single file or split it into multiple files. You group your resources with group keyword followed by identifier. Define the resources, providing the resource template for which it can contain dynamic parameters. You define actions by adding the HTTP method and when you can describe requests and responses. Application JSON automatically adds the content type header, but you can define it manually. You can move parts of the documentation to different files to reuse them or make maintenance simpler. You can define multiple responses for request. Congratulations, you just wrote your first API documentation. Unless your application is a simple one, most of the time you will want to separate front-end and API. Our application is a hybrid in that it contains the application and API in the same code. For that reason, it breaks a few REST rules, like having to be stateless. Just call your API RESTful and remember that rules can be broken if there's a good reason for it. Don't follow them blindly. We can consume our API with jQuery, as we are already using it for our front end. We have the dashboard page, which is available only to admin users, and loads a list of events with volunteers. The data with events will be retrieved as a JSON using getHTTP method. We define the onClick handler and stop the behavior as we don't want it to redirect to another page. We get the URL from the link and compile our handlebars template. GetJSON method will make a get method request to our API and will return data as JSON. After that, we check if we have any events with volunteers and output it to the page. Helper methods are nice, but we can make custom calls with jQuery. First, we find the elements we need and define a few helper functions. Add the handler, which will stop the form from submitting. We get the URL where request should be made, the method and form data. Using AJAX method, we can perform asynchronous HTTP request. We provide the data which will be sent using content type option in form that it will be JSON request. Using then method will provide two functions which tell what to do on success and failure. In our case, when request is successful, we inform about it and reload the page if there was no feedback beforehand. If the request was unsuccessful, we go over all the error messages and inform about them. Delete is almost the same, except that we use the delete HTTP method for the request. In this video, we learned how to document our API, how to retrieve and manipulate data from an API on the client side. In the next video, we will learn about how to provide CRUD through REST and how to aggregate our data. Hello and welcome to CRUD through REST video. In the previous video, we learned how to document our API, how to retrieve and manipulate data from an API on the client side. In this video, we're going to learn how to provide CRUD through REST and how to aggregate our data. The root method in Express.js allows us to define the resource once and chain multiple actions for it. The getHTTP method is used for data retrieval in REST APIs. In Express.js, we can define the handling of that request with get method. We will return a list of events with volunteers and return the data or an error. If an error happens, we want to make it as easy to understand as possible, so we provide as much information as we can. Using cache control header, you can change how the response should be cached by the client. If we got no errors, we send back the response to the consumer. In our event model, we have a method which returns the events with volunteers. MongoDB allows us to run aggregate operations on our data to process it and return computed results. We need to provide a pipeline of operations to be executed. First, we want to use $unwind operation to deconstruct feedback array and return document for each element in it. Then, using $match operator, we select only those documents that have volunteers. Using $project operator, we can change how our documents look, and we change them to only have a name and ID. We only want event name and total number of volunteers. This can be achieved with $group operator. It requires a unique ID by which documents will be grouped. We can sort our documents so that those with most volunteers be first in the results. The current documents are not in the representation we want them to be. Using $project, we again change how they look. Please read the documentation to learn more about aggregation. For creating resources which maps to post HTTP method, we can use post method in Express.js. First, this finds the event and prepares the data from request if no errors happened. Then, it calls the add feedback method on the model, and if it was successful, returns a response. The model has methods for finding user feedback in the document or checking if user left feedback. It has methods for removing user feedbacks and adding new feedback to document. The combination of those methods makes sure only one feedback from the user for an event exists. The response contains an event document which is returned exactly as it looks like in the database. You don't want this, as this compromises the security by displaying how your database is structured. If you change the field name, it might crash your API consumers. Before returning their response, you first want to transform the data. The simple way to do it is for Mongoose models to add toJSON method. The ret variable is what will be returned, and you can make changes to fields or remove them. The issue is that if you added a new field to the document, it will automatically be added to response. For that reason, you might want to take the whitelist approach. This will provide us with our wanted response. For updating the resource, which maps to put_HTTP method, we can use put method in Express.js. In this case, except for errors, it is almost the same code as for creating the resource. For deleting the resource, which maps to delete HTTP method, we can use delete method in Express.js. This finds the event, checks if user has left the feedback, and when tries to delete it. For example, this could have been changed to finding the event and returning the success response. It wouldn't matter if there was a feedback or if already was deleted. As long as the event is found, the delete always returns success. It would depend on how you are designing your API. In this video, we have learned how to provide CRUD through REST and how to aggregate our data. In this section, we learned what is REST, why use it, what is resources and methods in it. We learned how Express.js helps to build RESTful APIs, how to plan your API, and what authentication choices are available for an API. We learned how to consume REST API on the server using the API module, the native HTTP module, and API REST client module. We learned how to document our API, how to retrieve and manipulate data from an API on the client side. In the next section, we will learn about testing. Hello and welcome to the sixth section, Unit Testing with Mocha. In the previous section, we learned how to serve and consume RESTful APIs. In this section, we will learn how to test our applications. First, we will learn what is unit testing, what is testing-driven development, and what benefits testing provides. We will learn what is Mocha, what is char, and how to write tests. We will then understand what is a spy, what is a stub, and how to fake timers. Then we will learn what is Simon.js, what is a mock, and how to test our applications. Last but not least, we will learn what is Karma, how to configure it, and how to test our applications in the browser. Now, we move on to the first video of this section that deals with unit testing and TDD. In this video, we will see what is unit testing, test-driven development, and the benefits of testing. Unit testing is a software testing method. During each individual unit of code is tested to confirm that it is behaving as expected. This is done by validating the return values with the known values for that input. The unit should be the smallest testable piece of application, like a class or a function. Unit tests are small pieces of code that tests the application code. Each test case should be independent from other tests or units. The goal is to isolate each part of the application to show that individual parts are correct. The unit tests provide a strict contract which must be satisfied. Test-driven development, TDD, is a style of programming where coding, testing, and design happens in the same process. It defines the cycle where developer writes a failing unit test, writes enough code to make the test pass, and then refactors the code. All the steps are important and should not be skipped. Writing a failing unit test makes sure that your test is correct. If the test is passing when it shouldn't, then your test is broken, or your application already has that functionality. Writing enough code to pass the test makes sure you won't waste time writing complex solutions. For example, you are writing a calculator and the only thing you want to test is that sum method with 1 and 1 returns 2. Your code for sum method would be just return 2. Your brain might be screaming that that is not correct and it should be implemented to sum any value. It is correct if the only operation you would do is the sum of 1 and 1. It is better to move to writing code which provides more value to the business. I would suggest to watch the following testing kata videos. The language used is PHP, but what is important to take from them is how your mind should think when using test-driven deployment. Refactoring means that your code is changed to make sure it's easy to understand and maintain. During this setup, you remove duplication, move code around, change variable names. The before and after might be like comparing day and night. You don't need to be afraid of making changes, because if after refactoring all your tests pass, you haven't broken anything. During this step, you remove duplication, move code around, change variable names. Don't get too attached to the tests and vanity metrics. If the test is not providing any value, it's fine to remove it. Unit testing provides a lot of benefits. You can find problems early while it is cheap to fix them. You can get better understanding how the unit works as you need to think about it before writing code. When the bug is found, you should start with writing a unit test for it and only then fixing the bug. This approach makes sure that the bug won't be introduced again. You are confident that everything is working correctly when extending functionality or refactoring the code. Unit tests provide the documentation on how units work. By reading the tests, developers can learn how to use it. Tests define how the unit should behave, not how it should be implemented. Testing provides the increase in focus and productivity as your tasks are split into smaller tasks. The confidence provided by the tests allow you to experiment. Not everything is positive, and you should keep the following in mind. Working unit tests doesn't mean that errors won't happen or that the application as a whole will work. Tests can be buggy, in which case providing the false confidence of everything working correctly. This is the reason why you always make sure that your test is failing first. The tests will require the extra time to write them. This will be balanced out as you will be spending less time debugging to fix the bugs. Some might look at writing tests as a waste of time. Fixing bugs provides a false sense of productivity than having no bugs at all. Writing tests shouldn't be looked at as a different task from writing code. The code should be a single task which includes tests and code. You will be testing your code. The question is, will it be done manually or automatically? Congratulations! Now you know enough to start with automatic testing. In this video, we learned what is unit testing, what is test-driven development, and what benefits testing provides. In the next video, we will learn about what is Mocha, what is char, and how to write tests. Hello and welcome to the Mocha and char video. In the previous video, we learned what is unit testing, what is test-driven development, and what benefits testing provides. In this video, we're going to learn what is Mocha, what is char, and how to write tests. Mocha is a feature-rich JavaScript testing framework. It runs on Node.js and the browser, simplifying asynchronous testing. Mocha tests run serially to allow flexible and accurate reporting while mapping uncaught exceptions. You can install it with npm install --save-dev command. This will install Mocha as a development dependency. Installing this way allows everyone to know what for development your application depends on the Mocha module. To run Mocha, you have to provide the full path to it. You can install it globally. This way, it can be run without specifying the path. Char is a BDD, TDD assertion library that can be paired with any JavaScript testing framework. It can be used in Node.js and browser. Char provides several interfaces allowing you to choose the one you are most comfortable with. Behavior-driven development is the software development process that emerged from test-driven development. BDD focus is the desired behavior and the business value a feature provides. BDD style provides an expressive language and readable style. TDD style is a classic testing style and works by asserting values. Char can be installed with npm install command. To write the test, start by describing it. The describe method groups the tests in a logical manner. Choose the structure which makes sense for you. By using the it method, you define the test which will be executed for that feature. The test case doesn't have a callback. For that reason, it's marked as a pending test. If you want to test asynchronous code, omit the callback from the test case. If you want to test asynchronous code, invoke the callback after your test is done. The callback function accepts an error so you can use it directly. The hooks in Mocha allow you to control the setup and cleanup of your tests. Using before and after, you define what is being done for a whole block. Using before each and after each, you define what is being done for each test case. This, for example, allows you to put the database to a known state before executing each test. Mocha has a lot of options to change how it behaves. For example, we might not want for tests to continue if at least one of them failed. We can add the bail option to stop the test run after the first failure. We might want to change the reporting depending on the environment. Please check the documentation to learn more about Mocha. Char provides us with 3 different styles for checking if our tests are correct. Our examples will have all of them to display the difference, but you should choose a single one and stay with it. You get 3 interfaces: assert, expect, and should. Notice that should is executed as a function. For BDD style, you get some changes which are used to improve the readability for the assertion. You can assert the type of the value with an a or is something methods. It is possible to provide a custom message for assertion. An alternative to testing the target type is available. Should extends the prototype, but it is not always possible to do that. For those cases, it provides a few helpers to deal with them. If we need to check that the target is equal to the value strict equal, and equal methods could be used. The length of the target can be checked with length of or length methods. You might need to check the target is above or below some value. This can be done with above and below methods. While testing your code, you might need to check that some function throws or doesn't throw an error. Congratulations! Now you know how to write tests using Mocha and Char. Check the documentation to learn about what assertions are available. In this video, we learned what is Mocha, what is char, and how to write tests. In the next video, we will learn about what is a spy, what is a stub, and how to fake timers. Hello and welcome to the spying and stubbing video. In the previous video, we learned what is Mocha, what is char, and how to write tests. In this video, we are going to learn what is a spy, what is a stub, and how to fake timers. Spy is a test double which records its actions. After code execution, you can check if interaction is as expected. You can use it to make sure the method was called. It can be a synchronous function, or it can wrap an existing function. When wrapping an existing function, it will behave normally, but you will have access to data about all calls. Sign-on.js allows using the spy method to create an anonymous spy, spy on provided function, or spy on the object method. Let's see spying in action. We create a spy for an object method. Next, the method of our object is called with different arguments. Now, we can check the spy to see if interactions are as expected. We can check how many times the spy was called. We can check how many times a method with provided arguments was called. We can also check that the method was never called with some argument. We can make checks on the individual calls by returning them with getCall method. We can get individual arguments from args array. We can check that the call returned a provided value. Stub is the next simplest test double after the dummy. It doesn't have any expectations about the object behavior. It behaves in a specific way when put in a specific environment. Like with spies, they can be asynchronous or wrap an existing function. When wrapping an existing function, the original function is not called. You want to use stub to test a specific path. For example, throwing an error to test the error handling. You want to use stub to prevent calling a specific method directly. For example, making a request to an API. Sign-on.js allows using the stub method to create an anonymous stub, a method stub, or an object stub. Let's see stubbing in action. Now we can define that this method will return when called with an argument or by default. Our method returns an argument provided, but because we've stubbed it, it returns the defined value. We can define the value that will be returned on the specific call. By default, it will return the 9. On the first call, it will return 1. On the second call, it will return 2. On the fourth call, it will return 4. Make the calls and check the values. Stubs can also throw errors on the method call. You will notice that the method call is wrapped in error constrictor, as it won't be asserted if it was just called normally. If the code you are testing uses the timers, you need to fake them. You don't want to be sitting around waiting for that function which executes after 5 seconds. The useFakeTimers method replaces the global timer implementations. You will want to restore faked methods after the test is done. We have a function which executes after a second passed. The tick method moves the clock ahead. As less than a second passed, the timed out function is not yet called. By moving 1 millisecond ahead, enough time passed that the function is executed. You will notice that our test takes only 13 milliseconds to run. Congratulations! You now know how to spy and stub to make testing easier. In this video, we learned what is a spy, what is a stub, and how to fake timers. In the next video, we will learn about what is Sign-on.js, what is a mock, and how to test our applications. Hello and welcome to the Mocking with Sign-on.js video. In the previous video, we learned what a spy is, what a stub is, and how to fake timers. In this video, we are going to learn what Sign-on.js is, what a mock is, and how to test our applications. Sign-on.js is a library which helps you with writing your tests. It supports spies, stubs, and mocks for JavaScript. This makes it easier to test the code which has dependencies. Sign-on.js has no dependencies and can be used with any unit testing framework. To install it, use the npm install command. Mock is a test double which simulates behavior, and we have expectations for it. You define predictions for it and later check if any of them failed. You should avoid mocking domain or business objects. Mock is created with mock method, which takes the object to be mocked. With expects method, you add expectations for the object method, in this case to be called only once. In the end, you verify that expectations were met. One of them will fail, because the method was never called. Most of the time, you will be using mocks for dependencies. An object we are testing from one of its methods is calling a method on another object. For example, this dependency could be a database called from your feedback model. By mocking the dependency, we can add expectations for it, like making sure it was called between 4 or 6 times. To make our code easier to test without using mocks, we can use a dependency injection design pattern. You will want to restore all mocked methods between tests. One way to do dependency injection is by providing dependency as an argument. You will notice that we don't have from dependency in our terminal, meaning that the original method was not called. If dependency is not provided, you can throw an exception or do some default action depending on requirements. Dependency injection allows us to avoid mocking and provides fakes for dependencies. Let's add a few tests for our application. First, install the dependencies we will need with npm install command. Add the test script to package.json, so every time you run npm test, it is executed. We export different value for test database and run mocker with short timeout. This special mocker options file adds the recursive option to the mocker command. Let's test our event model. We will test this model using the database, so first we need to connect to it. We want to put the application in the no state. Using before each function, we drop the events collection and add test data. Now test that the model is found and it is the model we expected. We can mock the database, avoiding the need to have a database running. We create a sign-on sandbox to avoid manually restoring mocked objects. Now create the mock of the object and expectations for the method. Calling the mocked method will return a response we can make assertions against. We can test our controllers without depending on the Express.js application. First, move the handler to a module. Now, as the login handler doesn't depend on anything else, it can be easily tested. First, create the request, the response, and the spy. Now, just call the login handler and check that it was called. We can test that our application behaves the same way it's supposed to behave. Using the supertest module, we can check that a page returns an expected status code. We can make a post JSON requests too. You can add the continuous integration service to automatically run tests every time it is committed to version control system. Congratulations! Now you know how to use mock in tests. In this video, we learned what is Sign-on.js, what is a mock, and how to test our applications. In the next video, we will learn about what Karma is, how to configure it, and how to test our application in the browser. Hello, and welcome to the Running with Karma video. In the previous video, we learned what Sign-on.js is, what is a mock, and how to test our applications. In this video, we are going to learn what is Karma, how to configure it, and how to test our applications in the browser. Karma is a test runner for JavaScript. The main goal of it is to bring productive testing environments to developers. The environment being something that doesn't need a lot of configurations. It is a place where you write code and get instant feedback. Getting a quick feedback allows you to be productive and creative. Karma is used for testing the front-end code on real devices in any browser. It is testing framework agnostic and integrates with many contiguous integration services. Before we start using Karma, we need to install it using npm install command. Now, run the Karma init command to initialize a configuration file. Select Mocha as a testing framework. Our front-end code has dependencies, so we will need to use require.js. We will test our code in Chrome Canary and Phantom.js browsers. Skip the files for now, as we will add them manually later. Generate the bootstrap file and watch the files for changes. The initialization added a few dependencies to our package.json file. But we need more. These will extend functionality of our tests. Now, update the Karma configuration file. Add the char and sign-on to frameworks. Add the source and test files. Included as false means they won't be added to the browser. Exclude the application file as we don't want to launch it, and we will be controlling everything through test main file. Move the generated bootstrap to Karma test directory and add paths to our front-end files. Only this file will be loaded in the browser, and the rest will be loaded by require.js module loader. We need to configure our front-end code so it would use the loader too. First, install it with npm install command. Then, make the script available for the public and configure it. We define the paths for scripts and define our main application module. You will notice that paths don't include the JS suffix. Remove the scripts from the main layout and tell require.js to load our application module once it has loaded. Our main module looks almost the same as it looked before, except that we define the dependencies it has. The dependencies are provided to the function and can be used from it. You will want to avoid using anonymous functions as they are impossible to test. By moving the handler function, we are able to test only it without requiring any interactions. The dashboard module won't load jQuery as it's already loaded, but it will load handlebars as it depends on it. To make testing easier, you will want to move as much as possible to separate functions. This will make mocking and testing easier. Now to testing our dashboard module. Start by loading the dependencies the test will need, and the test and sign-on sandbox for mocking. Define the variables we will be using in the test. We define the spies and stub for getJSON method. As the jQuery code used in the front end uses the promise, our stub has to return one. Now, mock our dashboard module functions. It's fine to mock them, as other tests should validate that they work as expected. Call the event handler which we want to test. All that is left is to verify that the results are as expected. To make it easier to run Karma tests, add a script entry to package.json. Run this new script with npm run command. Karma will open the required browsers and test the code on them, providing you with results. It will keep watching the files to run the tests again. Congratulations! Now you know how to test your application in a browser. In this video, we have learned what is Karma, how to configure it, and how to test our applications in the browser. In this section, we learned what is unit testing, what is test-driven deployment, and what benefits testing provides. We learned what is Mocha, what is char, and how to write tests. We learned what is spy, what is a stub, and how to fake timers. We learned what is sign-on.js, what is a mock, and how to test our applications. In the next section, we will learn about shipping and deploying. Hello and welcome to the 7th section, Shipping and Deploying. In the previous section, we learned how to test our applications. In this section, we will learn how to package your applications and deploy them on the cloud. First, we learn what is dependency hell, what is semantic versioning, and why use it. We will learn what is package.json file, how to create it, and what's inside it. Then, we will understand what is npm, how to prepare the package for publishing, and how to publish to npm. We will learn what is platform as a service, what is Heroku, and how it works. And last but not least, we will see how to install Heroku Toolbelt, how to deploy an application, and how to configure it. Now we move on to the first video of this section that deals with dependencies and semver. When making a web application, you will be using a lot of packages written by other people. You will do this to avoid having to write everything yourself. The bigger your application grows, the more packages it will use. The more packages you use, the higher is the chance to end up in dependency hell. Dependency hell is a term used than versions of packages used to conflict and makes it harder for you to proceed with building your application. You have to be careful with managing your dependencies. If you make the constraints too tight on the dependency, you might not be able to update it, or it will constantly require input from you to update. If you make the constraints too loose on the dependency, there is a high chance that a change in the dependency could break your application. Semantic versioning, or semver, is a set of rules and requirements that dictate how version numbers are assigned and incremented. They are based on widespread common practices and better defines that you could expect from the dependency. The rules have keywords must, must not, required, shall, shall not, should, should not, recommended, may, and optional to better define those rules. There is 11 rules, and we will learn the most important parts about them. The software that uses semantic versioning must declare a public API. This API could be in the code or in separate documentation. The normal version number must take the form of x.y.z. The x, y, z are non-negative integers without leading zeros. X is the major version. Y is the minor version. Z is the patch version. Each element must increase numerically. Once the version package is released, it must not be modified, and all modifications should be released with a new version. Major version of 0, 0.y.z, is for initial development. The public API should be considered unstable and could change at any time. After the stable version is released, 1.0.0, the version number changes depending on the changes made to public API. Patch version Z must be incremented if only a backwards compatible bug fixes are introduced. Bug fix is an internal change that fixes incorrect behavior. Minor version Y must be incremented if new backwards compatible functionality is introduced. Patch version must be set to 0 when minor version is incremented. Major version X must be incremented if any backwards incompatible changes are introduced. Patch and minor version numbers must be reset to 0 when major version is incremented. Semantic versioning allows the dependency to better communicate its intentions. If application is very important, the developer can choose to use the exact version of the dependency or only update to bug fixes. If the application is not that important, the developer can choose to make the requirements looser and make the maintenance of the application simpler. Check the semver.org if you want to learn more about it. In this video, we learned what is dependency hell, what is semantic versioning and why use it. In the next video, we will learn about what is package.json file, how to create it, and what's inside it. Hello, and welcome to the package.json video. In the previous video, we learned what is dependency hell, what is semantic versioning, and why use it. In this video, we are going to learn what is a package.json file, how to create it, and what's inside it. Managing dependencies manually is a tedious and time-consuming task. We can automate this with an npm package manager. The package manager uses the information in package.json file to do its work. A package.json file affords a few benefits for you. It serves as documentation for what packages your application depends on. It allows to define the versions of packages using the semantic versioning. It makes your application easy to reproduce, which allows to share it with other developers. Package.json file must have at least a name and version fields in it. You can create the package.json file manually, or you can use npm init command to generate it depending on your answers. This will create a package.json file with answers you're provided. From now on, you can make changes to it manually. If you will add --save or --save-dev flags to npm install command, those dependencies will be automatically added to the package.json file. The package.json file contains a lot of fields. The most important of them are name and version. They are required, and your package won't install without them. They make a unique identifier for your package, and each change to the package should change the version. The name field has some rules, like being shorter than 214 characters, without dots or underscores. In lowercase, with URL-safe characters. It is advised to keep it short and not use the name which is already taken. Avoid putting JS or Node in the name, as it's assumed you're already making a JavaScript package. The name can be scoped if it is preceded by an ETA symbol and followed by /. The version field should use semantic versioning and be parsable by semver parser. The description is a short string which helps people to discover your package. The keywords is an array with strings which helps people to discover your package. The bugs is a URL to an issue tracker or email address to which issues should be reported. The license specifies the license for the package, so people would know how they are allowed to use the package. The homepage is a URL for the project homepage. The author field is for the person who started the package. The contributors field is an array containing the people who helped to develop the package. The files field is an array of files to include in your project. Certain files are always included or always ignored regardless of settings. The main field is a module ID that is the primary entry point to the package. The bin field maps the executable files to the command names to be installed. The directories field indicates how the package is structured. The repository field specifies where the code lives and is helpful for people who want to contribute. The scripts field contains script commands that are run at various times or custom scripts you want to execute using npm run command. The config field contains configuration parameters for package scripts. The dependencies field contains the dependencies and their versions for the package. The dev dependencies field contains the dependencies and their versions that the package uses during the development. It will contain the dependencies used for testing, documentation, and similar tasks. The peer dependencies field contains the plugins of the package. The bundle dependencies field contains the names of the packages that will be bundled when publishing the package. The optional dependency field contains dependencies that extended the functionality of the package but are not required for it to work. The engines field specifies the version of Node.js required for the package to work. The OS field specifies the operating system the package will work on. The CPU field specifies the CPU architecture the package will work on. The Prefer Global field specifies that package should be installed globally. The Private field prevents from accidentally publishing the private package. The Publish Config field contains the configuration values used at the published time. In the next video, we will learn what is NPM, how to prepare the package for publishing, and how to publish to NPM. Hello, and welcome to the Publishing to NPM video. In the previous video, we have learned a few things about package.json. Now we know how to create it and what to expect from it. In this video, we are going to learn what is NPM, how to prepare the package for publishing, and how to publish to NPM. NPM is the package manager for Node.js. It helps you to share and reuse the code. You should already have NPM on your machine. If not, please go back to video 2.2. We will be publishing our Hello Workout application to the NPM. Before publishing it, we first need to do some changes. First, we need to create the package.json file with npm init command. It will be published as a scoped package. For that reason, I'm starting it with my npm username. After the scope, provide the module name, and in this case, I include some random numbers to make it unique. Just name the package the way you want to, but remember, it has to be unique. Next, enter the version and short description. Enter the entry point, test command, repository, keywords. For the author, I use the shorthand, where you provide the name, email, and website. Change the license to MIT and generate the package.json file. Now we have the basic package.json file. The pre-version script will run the tests before bumping up the version to make sure our module still works. We set the Prefer Global to true, so the user will know this package should be installed globally. Map the files to global commands. This way, then you execute Hello Workout command, it will execute the index.js file. Set the Node.js engine to the version used because we know it works on that version and should work on the future versions. We need to install a few normal dependencies and a few development dependencies. Our Hello Workout changed by using Commander module to make writing command line interface easier. We also added some colors to the output. We moved most of the code to the module to simplify testing. Before you can publish the package, you need to register an NPM account. Fill the form and create your account. You can also create the account from the terminal using npm add user command. After you create your account, you need to log in from terminal with npm login command. Now, run the npm publish command to publish your package. The scoped packages are private by default, and publishing private modules, a paid account is required. Change the access to public when publishing the package. You only need to do it once for a module. Now, open your npm account page, and you should see the published package. We forgot to add the readme file to our module. Create a readme.md file and put the description in it. We didn't introduce new functionality or break an existing one, so only bump up the patch version. The message is optional, and as you can see, it runs our tests before bumping up the version. Now, publish the package again. Congratulations, you just published the package. Now you can install the package globally on your machine. In this video, we learned what npm is, how to prepare the package for publishing, and how to publish to npm. In the next video, we will learn what is Platform as a Service, what is Heroku, and how it works. Hello and welcome to the Heroku Basics video. In the previous video, we learned what is npm, how to prepare the package for publishing, and how to publish to npm. In this video, we are going to learn what is Platform as a Service, what Heroku is, and how it works. Platform as a Service, or PaaS, is a service that allows to develop, run, and manage web applications. It provides the platform to remove the complexity of building and maintaining the infrastructure. This allows developers to focus on developing their applications. PaaS provides a few advantages to consumers. It reduces the complexity, increases the speed of application development, and makes maintenance easier. Heroku is a cloud platform that lets you build, deliver, monitor, and scale applications. Their focus is on the applications, to be the service that allows you to produce value right away. Heroku works by combining many concepts to provide the platform for writing, configuring, deploying, and running applications. Heroku allows to deploy applications that are written in many languages. The application is defined by the dependency mechanisms. For example, it is a Node.js application if it has package.json file. For Heroku to launch your application, it needs to know what command should be executed. This is defined by procfile, which contains a process type and the command to be executed. Each line contains a separate process. The web process type is a special one, as it will receive an HTTP traffic. Git is the default way of deploying your applications. When you create an application, a new Git remote called Heroku is added to the repository. When you push this remote, your application is deployed on Heroku. When Heroku receives the application source, it will start to build the slug of it. The slug is the bundle of your source with fetch dependencies, configuration, generated assets, and everything else that might be needed to have the application ready for execution. That slug is put on the dyno. You can think of the dyno as a lightweight, secure, virtualized Unix container that contains your application slug in its file system. The configuration of the environment is kept in the config vars. At runtime, config vars are exposed as environment variables, allowing to change how your application behaves, for example, to which database it should connect. You will want to keep credentials and similar information out from source code. Releases are an append-only ledger of slugs and config vars. Each time you make a change or deploy, a new release is created and loaded on the dyno. Releases allow you to roll back to an old version. For example, if latest deploy broke the application. The dyno manager is responsible for keeping dynos running and healthy. Each dyno has its own file system. This is one of the things you have to keep in mind when developing an application which will be deployed to any cloud hosting provider. For that reason, you should avoid persisting for a long term to the file system and move to other services. For example, if you allow users to upload profile images, you will want to move them to Amazon Simple Storage Service, as otherwise all the images will be lost after the container is destroyed. Functionality of applications can be extended by adding add-ons. Add-ons are fully managed services integrated for use with Heroku. They are provided by Heroku or third parties, and can be such services like database, storage, email, and more. Heroku treats logs as streams of time-stamped events and collates them into a single stream. This provides a single source of activity. It keeps a limited buffer for log entries for performance reasons. If the dyno is running a process named web, it will receive HTTP traffic. The HTTP routers of Heroku distributes incoming requests across running web dynos. A random selection algorithm is used for load balancing requests. To be able to handle more traffic, all that is needed to do is to increase the number of web dynos. In this video, we learned what is Platform as a Service, what is Heroku and how it works. In the next video, we will learn how to install Heroku Toolbelt, how to deploy an application, and how to configure it. Hello and welcome to the Deploying on Heroku video. In the previous video, we learned what is Platform as a Service, what is Heroku, and how it works. In this video, we're going to learn how to install Heroku Toolbelt, how to deploy an application, and how to configure it. To manage Heroku applications, you will need to install the Heroku Toolbelt. Follow the instructions on the page to install it, depending on your operating system. Create a free Heroku account to get started. Now that you have a Heroku Toolbelt, log in using your Heroku credentials. You are ready to start creating and managing your applications on Heroku. First, we need to make some changes to our application. Change our start script to watch and add a new start script. Heroku automatically restarts the script on failure, but we still want to have auto restart when developing. Define the engines so Heroku will know which versions of Node.js and NPM to use. You should provide the same versions you use for development. In this case, we define 5.2 for Node.js and 3.3.10 for NPM. Next, in Procfile, define that command should be executed after the application is deployed. If you want to define more processes, add each of them on separate line. Next, install all the dependencies on our local machine. Node modules should not be added to the Git repository, and modules are installed automatically after they deploy. For that reason, you have to make sure that all the dependencies are defined in the package.json file. Create a .env file which contains all the environment variables used for local development. Credentials and other sensitive configuration values should not be committed to source control. If you will run the Heroku local, it will launch the application locally. It will automatically export .env file contents as environment variables. Create a new Git repository and then create a Heroku application. Git is used as the main delivery method for deploying your applications. The create command creates a new application and adds a new remote to repository. Commit your changes and deploy an application with git push command. With Heroku open command, you can open your application in the browser. The application won't work at the moment as it's missing some configuration values. Using Heroku add-ons command, add the Mongo lab, which will provide us with MongoDB. You will need to have a verified account to be able to add add-ons. With Heroku config command, we can check the environment variables. We need to add this to our configuration file. If you have an existing database, you don't need to add the add-on. and could simply just set the environment variable with config set command. With add-ons open command, you can open the add-on dashboard in the browser. From here, you can manage your add-on. Let's import our database dump. Get the user and password from environment variable and execute the mongo restore command. With config set command, add the remaining environment variables. Congratulations with deploying your application to Heroku. With Heroku logs command, you can see the logs your application is generating. Tail flag means to continually stream the logs. With Heroku run, you can run the command in the same environment as your application. Will this create one-off dyno, which will be destroyed at the end so your changes won't be persisted? You can lower the size of the slug by excluding the files that are not required for your application to run. For example, you could exclude the tests, PDF assets, and so on. You can scale your application with pscale command. Scaling up or down will change how many resources an application has. If you don't need the application anymore, you can permanently destroy it with Heroku destroy command. In this video, we have learned how to install Heroku Toolbelt, how to deploy an application, and how to configure it. In this section, we learned what is dependency hell, what is semantic versioning and why use it. We learned what is a package.json file, how to create it, and what's inside it. We learned what is NPM, how to prepare the package for publishing, and how to publish to NPM. We learned what is platform as a service, what is Heroku, and how it works. In the next section, we will learn about ramping up our full-stack JavaScript. Hello and welcome to the 8th section, Ramping Up on Full-Stack JavaScript. In the previous section, we took a dive into shipping and deploying our app. In this section, we will learn how to improve our application and its performance. First, we will learn what is page performance, how to improve it, and tools available for analyzing it. We will also learn what is an isomorphic application, what benefits it provides, and see an example of an isomorphic application. We will understand what is Webpack, how to install it, and how to configure it. Then we will dive into what is Redis, how to add a job queue, and how to create workers. Last but not least, we will learn why use a cluster, how to create a Node.js cluster, and how we could improve an application or development workflow. Now we move on to the first video of this section that deals with optimizing page performance. Now, let's learn what is page performance, how to improve it, and tools to analyze it. There are two ways the page performance could be categorized. The actual performance is how fast everything loads and is ready for work. The perceived performance is how it looks like to the user. Displaying something on the page and then loading the rest will look faster than loading first and then displaying everything on the page, even if both of them take the same time. If loading is fast, but rendering it on the page takes a lot of work, it might look slow or sluggish to the user. Page performance is very important. If the application is slow, the user will get frustrated and leave, leading to lost revenue. Even milliseconds can mean gaining or losing thousands of dollars. Google takes the page performance in the rankings, meaning that you might get lower search ranking just because your page is slow. A lot of people are starting to use the web through mobile devices, what can be slow on the network. About 80% of the page performance is influenced by front-end. Biggest culprits are images, scripts, and styles. Each external resource requires an additional request to retrieve it. For images, this could be fixed by creating an image sprite. An image sprite is an image made from multiple images. This way, you have less images to load and they are immediately available. For example, if you have a custom element which changes the look on hover, the effect will be immediate, rather than having to wait for an image to load. There is a lot of tools that allow you to generate an image sprite and CSS. For scripts and styles, you could concatenate them into a single script and styles file. Then, you could run the minification on those files to decrease their size. Minification is a process of removing all unnecessary characters from source code without changing its functionality. Script tags block the page rendering. You will want to use as few script blocks as possible or put them at the bottom of the page. Avoid changing DOM often, as it's an expensive operation. Try to keep the on-the-fly style changes and animations to a minimum. If you have to use them, try to use the native functionality rather than some library which makes it available through some other methods. The Content Delivery Network, CDN, should be used for serving static assets. This way, the client gets them from the server closest to their location. Optimizing and compressing images can reduce their size a lot. There is not a lot of point in saving a few kilobytes in scripts if megabytes are being wasted for loading images. Often, you can get up to 75% size reduction without losing quality. There is multiple online and native tools for optimizing the images. For analyzing the page performance, you could use the web developer tools included with your browser. On Network tab, you can see the requests made, how long they took, and their size. The Timeline tab allows you to record and analyze all the activity in the application as it runs. You get a complete overview of what happened and how long it took. First, you record that you want, and then you analyze the data for performance issues. You can change your network speed to test how your application will behave on slow networks. YSlow, provided by Yahoo, analyzes the page, gives you a grade, and suggests the changes you can make to improve the performance. PageSpeed Insights is provided by Google and similar to YSlow. GTmetrix analyzes the page and provides a lot of data about it. It provides the results from PageSpeed and YSlow, gives you the waterfall chart, and allows you to see a video of your page rendering. There is a lot of tools online that help you with analyzing page performance. Just find the one you are comfortable using. Congratulations! Now you know what impacts page performance and how to improve it. In this video, we learned what is page performance, how to improve it, and tools available for analyzing it. In the next video, we will learn about what is an isomorphic application, what benefits it provides, and see an example of an isomorphic application. Hello and welcome to the isomorphic JavaScript video. In the previous video, we learned what is page performance, how to improve it, and tools available for analyzing it. In this video, we are going to learn what is an isomorphic application, what benefits it provides, and see an example of an isomorphic application. Isomorphic application is one what can use the same code on the server and client. Web applications are made from multiple components that contain the same basic logic. For example, your back-end could be in Ruby, and front-end could be a single-page application in Angular. Now, if you had some validation logic, you would have to duplicate it on the front-end and back-end. If you wrote an isomorphic application, the back-end and front-end would use the same code, avoiding duplication. The code might need some checks to know in which context it is being executed, but all of it will be in the same place. Isomorphic applications provide a few benefits compared with normal applications. One of them is improved search engine optimization, SEO. This can be very important if your application is public-facing. As the contents are rendered as HTML, the search engines can index and rank your pages. Another benefit is improved performance. Large JavaScript applications take a long time to load, during which the visitor might get frustrated and leave. By loading all the content in markup and bootstrapping it later, the visitor can start using the application sooner. This, in addition, adds the progressive enhancement as you can use the application without JavaScript. The visitor gets basic functionality, and if all the requirements are met, it is extended after all the assets load. It will be easier to maintain your application as it is sharing the same code base. To make an isomorphic application, you could use React. React is a JavaScript library for building user interfaces. It is used to create reusable front-end components. React is developed by Facebook. It uses the virtual DOM to make only a single change on the DOM, making it much faster. React is too big of a topic to fit in a few minutes. If you want to learn more about React, check the material provided by Pact Publishing. We will make a quick glance how our application would change to make it isomorphic. We will be rendering a simple element on the home page. The Node.js module allows us to require JSX files from Node.js. JSX is a JavaScript syntax used for writing React components and is not mandatory to use it. Now, include the React modules and create the application. Using render2string method, we convert the application to a string and provide it to our template. The template has an element inside which the converted markup is outputted. Our application doesn't use require.js anymore and will be bundled with Webpack, about which we will learn in the next video. After the application is created, we check in which context the code is being executed. We want to render application in the browser, so we check if window variable is set. If this is being executed in the browser, and this is the page which contains the React application, we render the application after load. Our application will render a custom info component. Our info component is a simple div statement with some text. Now, if we open the home page, we can see the element is rendered. As you can see, the element is inside the page source. If, for example, we disabled JavaScript, this element would still be rendered. If we would not render the application in the server, you could see that without JavaScript running, there would be no info element. After enabling the JavaScript, it would render the application normally. Congratulations! Now you should understand how to write isomorphic applications. In this video, we learned what is an isomorphic application, what benefits it provides, and seen an example of an isomorphic application. In the next video, we will learn about what a Webpack is, how to install it, and how to configure it. Hello and welcome to the Bundling with Webpack video. In the previous video, we learned what is an isomorphic application, what benefits it provides, and seen an example of an isomorphic application. In this video, we are going to learn what is Webpack, how to install it, and how to configure it. Webpack is a module bundler. It takes the modules with dependencies and generates static assets that represent those modules. Webpack allows you to split the generated assets to achieve better modularization. It can only process JavaScript, but by adding the loaders, it is possible to process other resources. It has the plugin system, which allows you to customize Webpack depending on your application requirements. Webpack can be installed through npm with npm install command. Depending on your project, you will have to decide how you want to install it. You could install it globally on your machine. You could install it as a dependency. If you want to generate your assets automatically, you will want to install it as a normal dependency. An example would be generating assets after your application is deployed and all dependencies are installed. If you want to generate your assets on local machine and save them in repository, you could install it as development dependency. There are multiple ways to use Webpack, but we will look into using it through configuration file. In Webpack config.js file, we will include the Webpack module and set up some paths. Context is the base directory for resolving entry option. We use the current directory. Entry is the entry point for the bundle. In this case, the object is passed to generate multiple bundles. Output is where generated assets will be saved. Loaders are transformations that are applied on a resource file. We apply a great Babel loader, which converts our JSS React components to vanilla JavaScript. Babel compiles ES6 to ES5, allowing you to use new features in browsers that don't support them. JavaScript isn't the only resource to apply loaders to. It is possible to transform other assets like CSS. Check out the list of loaders to learn more. We have the option for resolving modules and loaders. We need this for handlebars module to work. Plugins allow to extend the functionality of Webpack. If we process CSS using the loader, it will be added in JavaScript and inserted on the page using style tag. Using Extract Text plugin, we can move the CSS chunk file to a separate CSS file. Using Commons Chunk plugin, we can move all the vendor's JavaScript code into a separate file, leaving our application JavaScript slim. Check out the list of plugins to learn more. Add the build script to package JSON file. When building the set environment variable to production, the P flag will minimize and optimize the generated assets. Add the post-install script. This way, the assets will be generated after npm install command is done. Execute npm run build command to generate the assets. As you can see, this is generated for our application code. Load the generated assets from the layout template. If your strategy is to generate the assets after the deploy, add the build directory to .gitignore file to avoid committing them. Congratulations! Now you know how to build dependencies using Webpack. In this video, we learned what Webpack is, how to install it, and how to configure it. In the next video, we will learn about what is Redis, how to add a job queue, and how to create workers. Hello, and welcome to the Finishing the App video. In the previous video, we learned what is Webpack, how to install it, and how to configure it. In this video, we are going to learn what is Redis, how to add a job queue, and how to create workers. Right now, the scraping of events from Meetup API takes about 20 seconds. Most of that time is spent making requests to get the attendees. One way to improve the performance of scraping would be to use the queue for retrieving event attendees. That way, we have some results right away and can process the rest later. If the Meetup API goes down, or we have a lot of work, then we can deal with that without disturbing our main application. For the queue, we'll be using Redis, an in-memory data structure store which can be used as a database, cache, or message broker. Please keep in mind that Redis is very insecure by default. If you will be hosting it yourself, change the default configuration to improve the security. If you want, you can try the interactive tutorial to learn how to use it. Download the Redis and install it on your machine. On OS X, to install it, using Homebrew Package Manager, execute brew install Redis command. If you want, you can change the default configuration, for example, to require the password. Use Redis server command to run the Redis server with provided configuration. We will be using queue module, which is a priority job queue backed by Redis. Install it with npm install command. Save the Redis configuration to application config. Then create the queue for our application. Jobs are kept in memory until they finish or complete. We turn off events to save memory. We can also listen for Redis and queue error events. Update the exit function to shut down the queue. In this case, the workers will get 5 seconds to finish the current active job. Now, we will change our events model to use the queue for processing attendees. Start by defining the data for the job. Title is the special key, as it is used to display jobs in user interface provided by dashboard. You can create a new job by providing the type and data to create method. The priority of the job can be specified using priority method. It can be a number or a name which is mapped to a number. Attendees lists is not critical, but we would still like to provide it. Using attempts method, we can set how many times the job will be retried before marking it as a failure. The retry is attempted right after the job fails. Using backoff method, we can set how long would it be delayed before trying again. In this case, we change the delay exponentially. With TTL method, we can avoid stuck jobs that run for a long time. This will set how long the active job has before being marked as failed. With delay method, you can keep the jobs from being added to the queue for processing. For example, using delay, we could scrape for events every 10 minutes or each day 2 hours after midnight. Using save method, add the job to the queue. With log method, you can add additional information for the job at any time. To process the jobs, we can create a worker. With process method, we define the type and concurrency of jobs to process. We call done callback when the job completed. Provide the error to callback if it failed. For long-running jobs, you could update the progress with progress method. For example, you could use it to inform about the conversion of the video. Just for display purposes, we add a random failure. The module provides a user interface for managing the queue. Now, if we run the event scraping, you can see that it is much faster. Run the worker and see how the jobs are being processed. Congratulations! Now you know how to use Redis for a job queue. In this video, we learned what is Redis, how to add a job queue, and how to create workers. In the next video, we will learn about why we should use a cluster, how to create Node.js cluster, and how we could improve an application or development workflow. Hello and welcome to the Final Remarks video. In the previous video, we learned what is Redis, how to add a job queue, and how to create workers. In this video, we will learn why use a cluster, how to create a Node.js cluster, and how we can improve an application or development workflow. Please keep in mind that what Node.js calls cluster is actually worker threads. Node.js runs on a single thread. Today, machines have multiple cores which could be used to improve performance of our applications. Node.js provides a cluster module that allows to create child processes for doing the work. A child process shares the same server ports. The master process is used for creating new workers and controlling them. Creating a cluster might sound like it is a complex task, but it is actually pretty easy to do. Our original script requires the file that started the application. To create the cluster, we use cluster module. The cluster module executes the same process multiple times. Using isMaster, we check if the process is the master process. From OS module, we get the number of CPUs on the machine to know how many workers to create. Then, using the fork method, create the workers. When the worker dies, the cluster module emits the exit event. When this happens, a new worker will be created. This way, we are sure that our cluster always has workers. By listening to online event, we can inform when the worker is running. Add the middleware to include the worker ID and output it on the layout. Now, start the cluster, and if you reload the page, you can see that it is processed by different workers. If we kill the worker, a new one will be created. I'm using the Apache Bench to benchmark the application. This will make 150 requests, with 20 requests at a time. One test is run on a single application, and one on the cluster application. If we check the results, there is not a lot of difference in performance. This is because Node.js was designed and optimized for I/O operations. Let's imagine our application is a little more CPU intensive. We have a root which blocks the execution for 100 milliseconds. Executing the benchmark again, we can see that now there is a difference when using the cluster. Let's have some fun and play Russian roulette with our application. It has a root which randomly kills the process. On a single process application, this game does not go on for long, and when it crashes, our application is done. On the cluster, this game can go on for longer, and if we get an unlucky worker, it is replaced with a new one. Our cluster application is a lot more resilient. There is lots of ways to improve the application or development workflow. We could add monitoring to track the application statistics. We could use the Content Delivery Network, CDN, for delivering assets. We could use the Continuous Integration Service to automate the testing and deployment. We could create a tunnel to an application on our local machine. This would allow us to test our application with webhooks or from other devices. We could add the hooks to test our code before committing it to Git repository. With time and experience, you will learn more and start making your own personal workflow for development applications. In this video, we have learned why use a cluster, how to create a Node.js cluster, and how we could improve an application or development workflow. In this section, we learned what is page performance, how to improve it, and the tools available for analyzing it. We learned what is an isomorphic application, what benefits it provides, and seen an example of an isomorphic application. We learned what is Webpack, how to install it, and how to configure it. We learned what is Redis, how to add a job queue, and how to create workers. Congratulations on reaching the end of this course. During the course, we learned about the basics of Node.js and how it works. We learned that Node applications are made from. We learned how to create MVC applications with Express.js. We learned how to use MongoDB. We learned how to serve and consume RESTful APIs. We learned how to automatically test applications. We learned how to package and deploy applications. We learned how to improve applications and their performance. Now, take the idea you have in your mind and make an application from it. With practice and experience, developing applications will get easier and more exciting.